Hello and welcome to my Make Your First Game in Unreal Engine 5 tutorial. My name is MizzoFrizzo and I am very excited to bring you what I think is the most advanced Make Your First Game in Unreal Engine 5 tutorial on the internet right now. So as you can see, what we're going to be making is a third-person shooter. It's going to have all the bells and whistles, such as fully automatic fire, with ammo and reloading. We've got health. As you can see, we've got some nice bullet casings ejecting from our weapon. We've got particle effects and sounds. We've even got random spread of our bullets, depending on whether we are hip firing or aiming down the sights. It really is very nice. Now, I did say that this is advanced, but there's absolutely no reason why someone who's totally new to Unreal Engine 5 can't make this with me. I guarantee you that if you follow along, you will be able to replicate this in your project. So what we're going to be making is a kind of third-person tower defense game here. If I press a key to start the game, you'll see it says wave 1 starting, and we've got an alarm sounding. And then down this tunnel, we've got some zombies that are spawning and moving towards the gate. If I shoot them, they'll aggro and start running a bit faster. And when they reach the gate, they're going to start breaking it down. Obviously, the aim of the game is to not let them in and kill you. So we're going to take them out, and we can even hold F on this gate and repair it. It's quite slow because we want our game to be, somewhat difficult. And then each wave, more and more zombies will spawn. And if you make this game exactly how I've made it, I challenge you to get past wave 10, because it really gets quite difficult. So without further ado, guys, let me show you how to do this. Alrighty guys, for the record, I'm using Unreal Engine 5.3, the most recent version, and I also recommend that you use the most recent version of the engine that is available. And we're just going to create a new project using the third-person template. I'm going to leave this as blueprint. We're not going to be doing any C++ on this one. We don't need starter content or ray tracing. I'm just going to call this my first game and hit create. I'm going to give you a quick rundown of the editor here. So this main window that you'll see here is called the viewport. It basically displays the world, the level that you have open. You are able to hold the right mouse button and move the mouse around to look around. And while you're holding the right mouse button, you can use the W, A, S, and D keys to navigate inside of it, much like any first-person shooter. You can also press the Q key to go down and the E key to go up, like so. And while you've got the mouse button held, you can also scroll the mouse wheel to change the camera speed here. So if your camera speed is too fast and you're having trouble, moving towards something you want to move, you can scroll down on the mouse wheel and slow the camera speed down, and you can see up here what the camera speed is. You can also left click and you can move around the same with the W, A, S, and D and the Q and E keys. But when you move the mouse here, it won't look around, it will kind of pan around. Alrighty, so that's the viewport. Up here we've got the different widgets, so you can move objects, rotate them, and scale them. You can see this at work. If I select this cube here, we've got this move widget, so we can grab these arrows and move objects in the world. By the way, we can also change whether this widget is aligned to the world or to the object itself by clicking this and changing it to the object space. Now you don't see a difference here because this object is aligned with the world, but here we can click on this one to change to rotation, and we have this rotation widget here. So once again, you can grab these and you can rotate the object on these axes. And here's a good example of now that this object is rotated, it's no longer aligned with the world. I can change from the global space here to the object space, and now these axes are aligned with the actual object as opposed to aligned with the world like this. The next one along here is scale. If I click this, we now have this widget for scaling the object. We can scale it this way, we can scale it that way, we can scale it up and down, and we can also hover between two of these or all three to scale it on multiple axes. So if I highlight these two axes, I can scale it on both of these axes. I could do it on both of these axes, or I could do it on all three if I wanted to just scale the entire size of the object. By the way, you can also switch between these different modes by pressing W without clicking. You can press W for location, E for rotation, and R for scale. So that's how you can quickly switch between these modes. I can press W, I can move it over here, I can press E and rotate it this way, and press R to change the scale and maybe scale this down. And if I wanted to place this on the ground, I can press the End key, and that will bring it down to the ground. You've also got some snapping options here. So at the moment, grid snapping is switched on and to 10 units, and the units that Unreal Engine uses is centimeters. So this is grid snapping switched on to 10 centimeters. So when I move it, it will move in 10 centimeter increments. I could change this to 100, and now I'm moving it in 1 meter increments. Or I could switch this off, and then it's going to move infinitely smoothly like so. And it's the same with rotation. So rotation snapping is currently switched on to 10 degrees, which means it's snapping to 10 degrees when I rotate, which is handy if you want to quickly rotate something, for example, by 90 degrees. I can easily do that. Or I can switch rotation snapping off if I want to just fine tune this, if I want to rotate it to exactly a certain angle, I can do that. And the same with scale. So if I press R to switch to scale, this is scaling at 0.25, so increments of 0.25, and I can also uncheck this, and then I can scale it smoothly to whatever I like. So once again, W to change to location, E for rotation, and R for scale. And we can change the object space, switch between the object space or the world space here. With scale, it doesn't actually change because that doesn't matter. But with location, for example, we can change between the... So you can see this is aligned with the object now, and I can move it along this axis, or I can change it to the world orientation and move it along these axes. Alrighty, so that's pretty much the basics of navigating in the viewport. A couple of the other things you might see here is up here we have the world outliner, and this is basically an outliner with that contains all of the objects and actors that are in the world. So if I select something here, you can see it's been selected up in the outliner. I can also select stuff in the outliner, and as you can see in the viewport, I have it selected over here. And these are grouped into folders for organizational sake. So you've got all of the lighting elements here, and you've got things like the player start, which is where our player will start when we hit play. We've also got down here, we've got a details panel, and this just contains all of the details of certain objects so that you can configure them. So for example, if I select this cube, You can see here the location settings. This is the world transform. This is the rotation and the scale. So you can see when I move the location, you can see the location changing in the details panel there. It's also got some other options, such as what is the static mesh that it is. So I can change the static mesh there. You know, whatever option, whatever object you have selected, you'll get a different set of details here that you can change. You can search for different details. You can also look at them in different groups, such as the rendering details or all, and that will show you all of the details that you can change on that object or actor. You've also got a world settings tab here. This will just basically be all the different parameters that you can set in the world. You know, there's a lot to Unreal Engine. I'm not going to go through everything, but basically these are the settings of the world, such as lighting and game mode and all sorts of different stuff. Down here you have the content browser. Now you may need to bring this up, I believe, by clicking down here, the content drawer, and then if you want to dock this content drawer, which I recommend doing, you just need to click dock in layout here, and then you've got the content browser right here, the content drawer. You're going to be using it a lot, so I recommend having it docked, and then you can just control how much space you want it to take up. If you want a bit more real estate for your viewport, you can just grab these, move them a bit out of the way. Yeah, so that's basically a quick rundown of everything you can see here. Oh, you've also got up here, you've got save, you've got to browse to the associated level. So this is browsing to this level, which you can find here, third person map, which is just the basic third person template map. It's just a little demo map that you can play around in. You've got the mode here, you've got selection mode, landscape, foliage, mesh paint, modeling, fracture, brush editing, and animation. We're not going to be going through many of these in this tutorial. We're going to be mostly in selection mode. Here you can find a button that helps you quickly add different things to your project. You can import content from a folder on your computer. You can access Quixel Bridge, which has a bunch of 3D assets and textures. Quixel Bridge is absolutely amazing. If I just bring up Quixel Bridge, you'll see that at the moment it's got a selection of 14,627 assets. And I mean, this stuff is amazing. These materials can go right up to 8K textures with nanite and tessellation and whatnot, and there's all kinds of 3D objects, from plants to pots and you name it. If I click on 3D assets here, you can see we've got them grouped by a bunch of different stuff, but we've got rocks and branches and tree trunks, and these are absolutely incredibly high quality. You can literally grab this stuff and add it to your project. You can download it and add it to your project down here. You can also just grab stuff and drag it into your world and drop it in there and start building your world. It's an incredible resource. So that's Quixel Bridge. You've also got access to the Unreal Marketplace here and your content browser, and then you've got basically a basic set of different things that you might want to drop into your world, such as a player start or a light, different kinds of lights, different shapes. So you could grab a cone and drop it in on the world, and then you have a cone. So this stuff is for blocking out your levels, basically. That's why that's there. You can block out your levels with basic shapes, which is good practice, instead of just trying to create a world with whatever, roads, trees, buildings. Usually what you do is you block out a level such as this level could be blocked out, and maybe this is a car or something, and you'll just make it the size of a car, and then later on you'll switch that out with an actual 3D model of a car. What else have we got up here? We've got some media stuff, visual effects such as sky and atmosphere, post-process volumes, all different types of volumes. You can also search in here, so you can just start typing and search for what you want to find. So you might go all classes, and then you want a player start. So you type player search, find a player start, drop that in. I'm just going to hit delete. We don't actually need that. And then we also have some blueprint options here, and add level sequence. This is the sequencer, which you can use to make cinematics and animations. And you've also got these controls here for the PI, which stands for play in editor. So I can actually hit play here, and if I click on the viewport, I have control of my character, and this is basically a quick test of what we have set up so far. So we've got the mouse to look around, WAS and D to move, space to jump, and if we want access to our cursor now, what we can do is press F8 to eject. So we've ejected from the editor here and ejected from the character, and we can even start looking around in the viewport. So this game is actually running at the moment. You can see the character is in an idle animation, and I'm able to look around. You can click on stop up here to stop the simulation, or while I'll press F8 again to uneject, or while you're in the player, you can also hit escape, and that will take you out of the simulation. That will end the simulation in the player in editor. Alrighty, yeah, that pretty much covers as much as we need to know for now. Now we are going to make your very first game ever in Unreal. I'm just going to delete these objects because we don't need them. They're just cluttering up the space. Everything that we do here is going to be super easy to follow. I guarantee you will be able to replicate all of this in your project. The very first thing we're going to do is download some animations and set up our character for our third-person shooter. So I am going to head over to the Unreal Marketplace here through the Epic Games Launcher. Once the Epic Games Launcher has fired up, make sure you're in the Marketplace tab here. I'm going to search for Animation Starter Pack and select this Animation Starter Pack. You'll want to add this to your project, and I'm just going to type my project name in here so you don't see all of my other projects. And it says that there's no compatible projects found, but you can click show all projects, select your project, and then down here, asset not compatible with version 5.3, please select closest alternative version. So the closest alternative version will just be the most recent compatible version. So I'm just going to select 5.2 here and add to project. That will download and add to your project, and you can close this. You'll know it's been added because we'll have this animation starter pack folder here. So here we have a whole bunch of animations, which if you open them up, you'll notice they are for, and by the way, if you have a tab or another window here, you can dock it by just dragging it up here and docking it next to your map. So I have my map here where I'm usually going to be working, and any other tabs I will dock up here. For some reason this is zoomed way out. I'm just going to right click and zoom right the way in here, and you will see that here we have an animation for the Unreal Engine 4 mannequin. So the first thing we're going to need to do is retarget these animations onto our UE5 mannequin because it uses a different skeleton, but luckily a retargeter is built in. They've given us a retargeter, so it won't be too hard. What I'm going to do in the animation starter pack is just right click and create a new folder, and I'm just going to call this retargeted UE5 anims, like that. So any folders or organizational stuff is really just up to you, how you want to organize your project so that you know where everything is and can keep track of what it is, where it came from. So yeah, you don't have to call it this, but I've just called it retargeted UE5 anims. And you'll see this little drop down here. This is a filter so that we can filter what we can see in the content browser here. Not all of these are animations. You'll see one of them here is a level, a showcase level. We've got a blueprint here for a character. We don't need that. We don't need anything that isn't an animation. So what we're going to do is click here, and in animation we will choose animation sequence. It's actually added to this list down here, so I just unadded it, my mistake. Animation sequence, and then down here you can check or uncheck any of the filters. So if I wanted a skeleton, I can search for skeletons in here. I can search for animation sequence, and then I'm going to press Control A to select all of these animations, and right click, and up here you'll find retarget animation assets, duplicate and retarget animation assets / blueprints. I'm going to click this and select an IK retargeter. The IK retargeter that we need is UE4 many to UE5 many, this one here. I'm also going to click change here and select the folder and find the retargeted UE5 anims folder that I created. Hit OK and retarget. This might take a few seconds. Got quite a few animations here to retarget. And basically what that retargeter has done is looked at those animations on the UE4 skeleton and then applied them to UE5 skeleton via the retargeter. We won't go into setting up retargeters or anything like that. This one's built in and it works quite well, as you can see. If we look, for example, at walk forward rifle iron sights, we've got quite a nice animation here retargeted onto the Unreal Engine 5 mannequin, ready for us to use. One other thing that I didn't mention before in navigating viewports is that you can hold Alt and click and it will stay focused on the object you're looking at. When you move the mouse around, it will rotate around, so that's quite a nice one. Another thing you can also do is you can select an object. Let's say you select an object here or in the world outliner. If you press F for focus, it will pull focus onto that object. Then you can hold Alt, click, and move the mouse to rotate around that object to check it out. So if I want to move to this player start, I can press F, and then there, I'm back at the player start. Alrighty, with these animations retargeted, what we're going to do now is look at a blend space. So we're not going to go in depth into an animation blueprint here, but like creating one from scratch, but we are going to edit the existing one. So couple of things I'll point out to you is down here you'll find a folder called third person, and in blueprints within third person you'll find the blueprint of our player character here. If you want to find what character your game is using, what you can do in world settings is look for this game mode override. This is the game mode here, but just to check which one's actually selected over here in the world settings, BP third person game mode, you can actually click this browse icon. You see it says browse to asset in content browser. If I click that, it will browse to the asset and select it. And then you can open up BP third person game mode, and here you'll find default pawn class. A pawn is basically a character. default pawn class is BP third person character here. You can also click on browse on that one and it will take you to the character. So this is the blueprint, the character blueprint that the game mode is using. When you hit play and play from this player start, you're going to use this character here, which we can also open up, and you'll be greeted by the event graph. Now, this is Blueprints. As some of you would know, Blueprints is Unreal Engine's visual coding system. So this system has hundreds of thousands of these nodes. These nodes are visual representations of bundles of code. So basically the whole bunch of code has been written that you have access to and you can use without writing any code yourself. And we are not going to be writing any code ourselves in this project. We're going to be using strictly blueprints, and this stuff is amazing. So you can see there's all sorts of different variables and mathematics going on to calculate world direction and an action value when you press the move keys, which then adds movement input to the character, looking around with the mouse and all sorts of things. It's absolutely incredible. So this is our character's blueprint. You've also got blueprints in different actors. You know, a door could be a blueprint, a loot box could be a blueprint, you know, you name it. You've also got these tabs up here. You've got the event graph, which we've been looking at, construction script, and viewport. And the viewport is the visual representation of what this blueprint is. Over here you can see a components tab. So these are all the components that this blueprint contains. Much like the world outliner, you can click components here and they will be selected in the viewport. So capsule component here is this capsule around our character, and it does basically the collision of the character. So this is basically the box that our character lives in. An arrow component, which is the direction it moves. The mesh is the skeletal mesh of the character. We've got a camera boom here, which is basically this arm that the camera is suspended on, and then the camera is a child of that camera boom. It sits in the socket at the end of the camera boom there. You can also see a character movement component here, which has all kinds of parameters for the character's movement in the game, such as gravity and max walk speed. So there's a bunch here, but I just want to point out max walk speed here. This is the max walk speed of our character. And actually, while we're here, we're going to change this to 150. So we're also going to, and we can do it right now actually, we're going to set up a walk and a jog. So we're going to change the default max walk speed to 150 here, and then over in the event graph we're going to go down here and find some empty space. We're going to right click and find left shift. So this is the left shift key. We're also going to drag this camera movement out into the graph, and so this is a reference to the character movement, and off of character movement we can drag from this pin and release it, and it will automatically bring down this pop-up menu of nodes that are contextually relevant to that node. So all kinds of stuff here. You can search for a node. You can also uncheck context sensitive, so now this has basically all the nodes, but for the most part we're going to want to keep context sensitive checked. And what I'm going to search for is set max walk speed. We can hit enter if it's highlighted, or just click on it and it will spawn this node that sets the max walk speed of the character movement component over here. I'm going to click and drag from here to here These are called execution pins. So when we press the left shift, it's going to execute whatever nodes are connected over here. Also, with this set max walk speed selected, I can press Control C to copy and Control V to paste, or if I just hit delete on this one, or I can hit Control D to duplicate. So I hit Control D and it will just duplicate that one to wherever my mouse cursor is. I'm going to plug this other one into released, and I'm going to plug camera movement into the target here. So when I press the left shift key, I'm going to set the max walk speed up to 500, and when I release it, I'm going to set it back down to 150. Now up here you'll see a button that says compile. This is very important. If you don't compile the blueprint, it won't work. It has to compile. So basically what a compiled language does is it converts it from a language that humans can read into the language that only the computer can read, which is much more efficient. So we hit compile here and save, and now if we hit play and click in the viewport, you'll see that when I move now, my walk speed is at 150, and if I hold shift, I can run like so. The next thing we're going to do, guys, is create a blend space with some of the animations that we retargeted from the UE4 mannequin. So we're just going to take a quick look at the animation blueprint that this character is using. So this is the character's blueprint, but then there is also another blueprint which dictates what animations the character plays in any given circumstance. So if I click on the root up here and then look over here in the details panel, you'll see animation mode, use animation blueprint, and the anim class here has the animation blueprint selected, ABP for animation blueprint underscore Quinn underscore C. If I hit browse here, it will browse to the animation blueprint, but if I open this animation blueprint, I'll just get a message that says it's a child of ABP Mani, and what that means is that ABP Mani contains is the actual blueprint, and then to create the separate animation blueprint for Quinn, what they've done is they've created a child anim blueprint. So this is kind of an introduction to inheritance. In Unreal Engine we use something called classes, and classes are made up of groups of blueprints, for example, that all inherit certain characteristics from their parent class. So you've got parent classes and child classes. We'll go into that a bit more later on, but what we're going to do now is open up ABP Mani, because ABP Quinn is the one that's selected, but it's a child of ABP Mani, so every change we're going to make to ABP Mani. If we open it up, you'll see you've got two tabs here, the event graph and the anim graph. The event graph, to put it simply, is basically something that constantly checks all of these variables and constantly updates them so that the animation blueprint knows what animations to play at any given moment. So you can see, for example, here it's setting a variable called velocity and a variable called ground speed. So it's constantly updating and checking the movement speed of your character so it knows whether to play an idle animation or a walking animation or a running animation. You can see one here called should move, and this is starting to look more complicated here, but basically if you read what's going on here from the movement component, it's getting the current acceleration, and then this is a not equal node, so it's checking if the current acceleration is not equal to 0, and if our ground speed is greater than 3, then we should move. This is basically a variable that's created to check for very minute movements and disregard those when deciding to move from an idle animation to a walk or a run animation. So it will only move into a walk or a run animation if the ground speed is greater than 3 and the current acceleration is not equal to 0. And we've got one more down here which is called isFalling. isFalling is basically a built-in function in the movement component that tells us whether our character is touching the ground or not. So isFalling is a little bit misleading. It's actually is in the air or not touching the ground. So that's what isFalling is our character touching the ground. Up here we've just got some very initial, this is like an initialization, so when this blueprint begins, it's casting over to our character's blueprint, which we were looking at before. It's setting that as a variable, so it has a reference to our character's blueprint. Instead of this node that you can see here that says cast to character, casting is actually a little bit too expensive, a little too resource intensive. So what we, instead of casting, because this is going to be constantly updating, instead of casting over and over and over again, it's just on initialization, casting once, setting a reference to that character, and then you can use that reference to the character wherever you like down here. It's also, while it's casting over, it's grabbing the character movement from that character and also setting that as a variable. So instead of casting for the movement component, you can see here these references to the movement component. Instead of casting, we have these references, so it just uses the reference, grabs the velocity, sets it in this blueprint so it knows what the velocity of our character is. Alrighty, so that's the event graph. Over in the anim graph here, this is basically what animations are playing at any given time, and they all go out to this output pose, which is the current animation that's playing. Here you'll see locomotion, and if we go into locomotion by double clicking, you'll see this first state is an idle state, and then you've got these arrows which are transitions into different states, and this is the walk and run state, and you've got these little things here which are transitional rules. So if I go to the event graph, you remember I told you about this should move variable to see if our character should move. In our anim graph, the transitional rule to go from idle to walking and running, if I double click on this transitional rule, is should move. If you should move, you can enter that transition. And up here you can see a little hierarchy of the graphs that we're looking at, so I'm just going to click back to locomotion, and we're going to have a look at the transitional rule from walk run to idle. If I double click on this one, you'll see that they've got something here called a not boolean. So this basically means should not move, and then it can enter the transition back into idle. If I double click on this idle state, what you'll see is a sequence player here playing an animation, and the animation is idle, which is this animation that you can see playing in this viewport over here, and it is looping. So over here in the details panel, loop animation has been selected, and this is just, you can see by this little slider here, it's just looping this idle animation. If I click on locomotion up here to go back, I'm going to double click on walk run, and this one's going to look a little bit different, because this doesn't say sequence player, this says blend space player. And this is going to be your introduction into blend spaces. So this blend space is, I'm going to double click on it now to open it up, and it's going to open up in a new tab up here. You've got this graph down here, which you can see the horizontal axis is labeled speed, and this is just a one-dimensional blend space. So it just has this one axis. It's called speed, and based on the speed of our character, it's going to blend between different animations. So if I highlight this dot here, or I can actually click this little name tag thing here, and it will bring up the names of these animations. Here we've got walk in place, which is the one that you can see playing at the moment. We've got walk forward and run forward, and from speed 0 to speed 500. So you remember our default walk speed of the character was 500. If I hold control and hover my cursor over here, you can see what the blend looks like at any given speed. So right here in the middle of these two, it's a blend between walk in place and walk forward. It's a blend right here of those two, and then as we go up, it's starting to blend from walk forward into run forward, like so. Now, as I said, this is a one-dimensional blend space. We are now going to set up a two-dimensional blend space so that it's not only blending on speed, but also the direction that our character is moving. Now, this is not something that's usually introduced in a beginner's tutorial, but it's not too hard. Nothing in Unreal Engine is too hard once you know how to do it, and I'm going to walk you through absolutely everything that needs to be done to do this. Okay, so I am going to close this blend space, and this blend space here is the one that we're going to replace. By the way, you can see, so I said it's based on speed, so we've got this pin here for speed. That's the horizontal axis of that blend space, and ground speed is plugged into it. Over here in this panel here on my blueprint, you can see a list of bunch of different stuff. You've got the event graph here, the anim graph, you've got functions and macros and animation layers. We're not going to be going into any of those, but you've also got this section here for variables, and if I drop down these variables, we've got references, so the character reference and the movement component references that are created on initialization, as I explained, and our essential movement data: velocity, ground speed, should move, and is falling. And they have just plugged in this ground speed, get ground speed, and plugged it into here. Just going to delete that. Okay, so if we go back out to our main window here and go to our retargeted UE5 anims, we're going to create our blend space in this folder here. So I'm going to just find some empty space and right click, and I'm going to find animation and blend space here. So just FYI, under legacy down here you'll find blend space 1D. This is the single axis blend space that we were just looking at, but here we have blend space which works in more than one axis. We can create that, and now we need to select the skeleton that our character is using. So this is the skeleton that this blend space will apply to. It's SK mannequin, but you do not want to confuse this with SK mannequin skeleton, which is actually, if you look at the little icon here, it's the UE4. It's the UE4 skeleton, same as this one down here. UE4 mannequin skeleton and SK mannequin skeleton are both UE4. This one here, SK mannequin, as you can see in the icon, is Quinn. This is the one that we're going to be choosing. And then we got to name our blend space. I'm going to call it BS for blend space. Oops, I accidentally clicked out of that, sorry. You can hit F2 to rename stuff. I'm going to call this BS for blend space underscore directional move, like that, dir move. I'm actually going to call this dir move lower. I'll explain to you in a moment why. but basically we're going to blend between our lower body animations and our upper body animations so that we can have separate animations on our hands as we do on our legs. So bs_dir move lower, and then I'm going to open this up, and the very first thing we're going to do is define our axes here. So up here in the top left in asset details, you'll find axis settings, horizontal and vertical. We're going to drop down the horizontal axis, and we're going to change the name to direction. This is the direction that our character is moving in. The minimum axis value is going to be -180. The maximum will be +180. So these are degrees of rotation. So as you can see here, it's popped up with the details down here. Direction -180 to +180, and the center being 0. This is our rotation of our character. So this grid division here will be -90, 90 degrees left, 180 degrees left. This will be 90 degrees right and 180 degrees right. We can drop down the vertical axes here, and we can call this speed, and I'm going to change the maximum axis value to 500. The maximum walk speed of our character when we press the left shift. So here we can just start grabbing animations from over here and dropping them in the graph. The very first one I'm going to look for is an idle. Idle rifle hip right here. Idle rifle hip. I'm going to grab that and drop it in the graph here, and then I can either click and drag this animation around the graph. I could drop it down here and try to get it in the middle at 0, or I can change the details up here to direction 0 and speed 0. I can also do it over here in the asset details. I can find blend samples and the idle rifle hip right here, and I can change the speed that the animation plays and what speed our character should be moving at for it to play, and the direction, blah blah blah, but I don't actually need that right now. I am gonna grab idle rifle hip 2 more times and drag it down, and drag it down into the corners here, because you do want idle to, if you're stationary, you want it to play. So I'm just going to put it in the corners here for safety. The next thing I'm going to do is find walk, and unfortunately there's no walking with the hip fire here. It's all with iron sights, but we're going to blend that out later anyway. So I'm going to find walk forward rifle iron sights, and I'm going to put it here at about 150. I'm just going to make sure, I'm going to click on that and make sure direction is 0 and speed is 150. I'm going to find walk left rifle iron sights and put it here around this grid division. I'm going to find right and put it here. I'm going to find backward and put it here, and also backward is going to go over here. And I'm just going to click on each of these and make sure that the speed and direction of this are correct. So -180 for the direction, speed 150. And sometimes when you click now, they will auto change to what it thinks you're trying to do. So you can see there, I've clicked on that one, it's automatically changed to something completely wrong. I'm just going to hit this show sample names to find where it is, and you can see that we've doubled up here. So I want to grab the right one, move it back over here. That's something really annoying that Unreal Engine does in the blend spaces, is it automatically corrects to stuff that's completely wrong. Don't know how to switch that off yet. And there it goes again. So I want walk backward to be over here. Now these don't actually have to be exactly correct. As long as the differences are imperceptible, 151.82634. That doesn't matter, that's fine. So now I'm going to find jog forward rifle, and I'm going to put it in the middle all the way at the top here. Jog left rifle, I'm going to put on this grid division here. Jog right rifle here. Jog backward is going to go in the top right corners and the top left corners. I can save this and I can close it for now. And now we're going to put it into our enum graph, but first we need a direction variable. So as default, this doesn't come set up with a direction, the direction of your character. So we're going to set that up now. It requires velocity, so I'm going to do it at the top here. And how I'm going to do that is select all of these and move them down here to make some space up here. I'm going to add a pin here, and just FYI, if I hold Control and click and drag, I can move these executions onto different pins. So I'm holding Control, clicking and dragging, and I'm going to put my direction up at the top here. How I'm going to do that is I'm going to drag off of the character reference here, and I'm going to look for get actor rotation, and then off of get actor rotation I'm going to look for calculate direction, and it should be this second one here. These two are not exactly the same. It should be this second one. It's the one that says target is anim instance. I'm going to grab velocity here and plug it into the velocity, and then what I'm going to do is drag off of this return value and click promote to variable. This creates a new variable set off of this return value here and automatically gets you to name it. I'm going to name it direction, and then I'm going to click and drag this execution pin and plug it into the execution pin on the set direction here. If just a little tip here, if you're trying to organize your graph and you want things to line up, what you can do is highlight them and press Q on the keyboard, and they will line up nicely. There, we have created our first variable. Variables have many different types. You have Boolean, which is basically on or off, 0 or 1. And you've got a whole different bunch of types of variables. You've got an integer, which is a whole number. You've got a float, which is a a number with a decimal point. You've got a name of something, a string of letters and numbers. You've got vectors, which are three-dimensional lines basically. You've got rotators, which rotate things, and transforms, which move things and set their location. This one is just a float. I don't know why it's a float. If it's direction, you'd think it would be a vector or something, but anyway, it's a float because it's just the angle, so it's minus 180 to positive 180. Alright, so we've set our first variable, and it is direction, and now we have direction and ground speed. We can implement our blend space. So we're going to head back over here to our enum graph, and I'm going to select this blend space, and then over here I'm going to select the blend space by clicking here and selecting our blend space move lower. It's weird that it's not. I'm going to double click this and open this. Why have we not got a speed input? Very strange. What I might do is just delete that and grab our blend space here, drop it in. There we go. We have direction, which we can plug in here. We can just grab direction here and click get, or you can hold Control, click and drag, and it will do the get. If you want it to set, for example, if we're in the event graph here and we want to set direction, we can hold Alt and click and drag out, and it will drop a set direction. So once again, hold Control, click and drag for a get, Alt, click and drag for a set. So we can grab direction and ground speed, and instead of putting this and then plugging it in, what I can do is I can hold Control and click and drag to get the get, and then I can just drop it on that pin and it will automatically plug it in. I want to plug in the output here to the output animation pose, hit compile and save. Now that's all we need to do in here, but if I hit play right now, what you'll notice is that so there's a problem with the feet. So in the animation blueprint, I want you to click on the anim graph, go way out to the top here, and we're just going to delete this control rig. This is for the feet IK, so we're not going to have feet IK. That's something that's much more advanced to set up. We're just going to delete those and then plug the default slot into the output pose. Compile and save. If I hit play now, you'll see that we don't have the directional movement because our character's rotation is oriented to our movement, and that's a setting that we have got set up. So the character is always going to just do the jog forward or the walk forward because they're just always walking forward. So what we're going to do, I'm going to press escape. I'm going to go to my character's blueprint, and in the details panel I'm going to search for orient, and you'll see this orient rotation to movement. We're going to uncheck that. I'm also going to search for yaw and see this use controller rotation yaw. What this is it's going to use our left and right on our mouse to rotate the character. So if I check this one, hit compile and save, and now if I hit play, when I rotate the mouse it's going to rotate the character, and when I walk in certain directions it's going to play the animations that we've set up. There's one more issue here, which is the character's kind of floating here. What I'm going to do is in the character's blueprint I'm going to select the mesh, and I'm going to change the third argument here on the location to -93. That's going to drop our character down by 4 centimeters. If I hit compile and save now and play, our character is touching the ground now, and we have walking in different directions. Really looks quite nice. The only thing is that the feet are sliding a little bit on the walking animations, so let's do something about that right now. What we can do is go into our blend space, and then we're going to find our walk animations here down in the asset details panel. I'm going to drop all of these walking animation menus down, and I'm going to change the rate scale. Let's try 0.8, so it's going to slow that animation down. With that highlighted, I'm going to press Ctrl C to copy, and then I'm going to select each rate scale and press Ctrl V to paste. Just paste in 0.8 into all of them, and then hit save. And now if I hit play, a bit less sliding going on. A little bit of sliding, but let's try 0.75 real quick. Might be a little bit closer to what we want. 0.75, 0.75, 0.75, and now that's looking much nicer. Our feet aren't sliding along the ground as we move. You will notice that some of the angles, especially when jogging, forward and left and back and right, don't look quite right. That's because these are a blend of this animation and this animation, and just the way that the hips are turned with the strafing animations means that these angled ones don't work well. So usually in your blend space, you'll actually have sort of a left forward and a left back animation, and it will blend between all of them. But these, we're just working with the animations that we've got here, and that's all we've got for now. So you'll notice that also we have no aiming down the sights, or we have no idle. We have no idle with the hands. Our hands are up in the aiming from the sights position when we walk, and they're in the idle when we run. So what we're going to do is we're going to set up what's called a layer blend per bone to blend the upper body and the lower body, so that we've got some different animations up on the top as we do on the bottom. What we're going to do first is duplicate our direction move lower, so I'm going to click on it and press Control D to duplicate, and then I'm just going to change the name to move upper. These are going to be our upper body animations. I can open up move upper, and what I'm wanting to do is just make them all idle animations, as in idle with the hands. Hip fire is what I meant to say. So what we can do is just delete these aiming animations, delete all of those, so that we've just got idle and running. And actually what we might do is, let's find some other animations to put in their place. There's only walk and jog, and actually what we might do is copy these ones. So I might put jog forward down here as well, and these don't have to be exact, but basically this is just because otherwise down here you can see the upper body is just moving in slow motion. We want, so this is about where our walk speed is, 150, and we just want a little bit of bobbing and moving. So let's put these about here. This is just a very kind of hacky way, because the only things we're going to use from this blend space are the upper body. So we won't see the legs, we won't see the feet. The feet will just be going off that original blend space we made. Let's grab jog back, put it there, and put it there. It actually doesn't matter. Yeah, no, that's good. It doesn't matter too much, but yeah, let's see what the results are. So we can save this, and we're going to go back into the animation blueprint, and what we're going to do is I'm going to duplicate locomotion, and I'm going to rename it upper body anims, like so. And now what this is here is a saved cache. They are saving the output of this state machine. They're saving it in a cache, so then they can bring it up elsewhere, and we're going to do exactly the same thing. We're going to drag off of actually first I'm going to click on this, and up here in the top right in the details panel I'm going to Control C the name, and then I'm going to drag off of here, and I'm going to search for save, and we're going to go new save cached pose, and then I'm going to click on it and Control V to paste the name, upper body anims. I'm going to go into upper body anims, and I'm going to go into my walk run, and I'm going to select the dir move lower and change it to our dir move upper. I'm going to back out to the anim graph, and main states here, I'm going to drag off of that and find layer blend per bone. Okay, I'm also going to right click down here and find this cached pose. So upper, use cached pose upper body anims. This is going to be our blend pose here. And if I click on this layer blend per bone up here in the details panel, I'm going to leave the blend mode as branch filter, and in layer setup I'm going to drop this down and drop down the index, and then branch filters here, you'll see there's 0 branch filters. I'm going to add one, and then I'm going to drop down the index on this branch filter, and in the bone name, this is the bone of the skeleton where it's going to blend from. I am going to, and this is very important to spell this exactly right, is all lowercase spine underscore 03. I'm going to leave the blend space as 0, and I'm going to check both mesh space rotation blend and mesh space scale blend. And now what it's going to do is from the 3rd spine bone up, it's going to blend in everything from upper body animations. So now if I hit compile and save and hit play, now when I walk, you see I've got the hip fire position, and it's just all in the hip fire position. Very nice. Alright guys, I know it's a lot. I hope that was easy for you to follow so far, but now we have the bare bones of a third-person shooter set up with directional movement, and yeah, it's set up quite nicely. So let's get into some more fun stuff and add some weapons. Alrighty, so the next thing I'm going to do is click up here and head on back to the Unreal Marketplace. Once the Epic Games Launcher has loaded up, once the Epic Games Launcher has loaded up and the Unreal Marketplace, I am going to search for military weapons, and you'll find this military weapons dark. I'm going to click on this one, hit add to project. I'm going to find my project by clicking show all projects, and I'm going to select the most recent compatible version, which is going to be 4.27, add to project. Once it downloads and or adds to project, you can close this and you'll find this folder down here, military wep dark. And if you open up the weapons folder, you'll find all the weapons here, such as assault rifle B, which is the one we're going to be using. It's a pretty nice skeletal mesh, and it comes with some animations. If you go into this animation folder and find fire rifle W, you see an animation of it firing here with particle effects and all. Very nice. So this is what we're going to be using. How we're going to add it to our character is I'm just going to open up my character's blueprint, which once again is in third person blueprints and BP third person character, and I am going to add a component to this character. So over here in the components tab, I'm going to hit add, and I'm going to find skeletal mesh. This skeletal mesh component I'm going to call weapon, and I'm going to drag weapon, click and drag weapon onto mesh and make it a child of mesh. Okay, and then with weapon selected over here in the details panel, I can find the skeletal mesh asset, change that to our assault rifle B, but you'll see that this is not connected to where it should go. So how we're going to do that is we're going to create a socket in our character's skeleton. So if you click on the character's mesh here, over here at the right, you'll see the skeletal mesh asset that it's using. You can click the browse icon to browse that asset, and then if you open that skeletal mesh asset, up here in the top right, you'll see this skeleton button. You can click that and it will open the skeleton of that skeletal mesh. So this is the skeleton that our character is using, and what we want to do over here in the skeleton tree is search for hand and find this hand underscore R, which is the right hand. We're going to right click on it and go add socket, and we can just leave that as hand underscore R socket for now. What we're going to do is right click on that and add a preview asset, and the preview asset we're going to add is assault rifle B. You can start rotating this and moving it into place, but the first thing I notice is that it's a little bit big. I think it's not scaled correctly. So what we're going to do is head back to our BP third person character, select the weapon here, and click this padlock here. It's going to lock the scale so that it's uniform. If I change one, it's going to change all of them. And I'm going to change this to 0.8. You can see they've all changed to 0.8. And that looks a bit more like it there. So in the skeleton, what I'm going to do is in the relative scale of the preview asset here, I'm going to change it to 0.8, 0.8, and 0.8. Actually, that might do it twice. Does that make that even smaller? That's hard to tell. So with this at 0.8, I'm going to then start playing around with this socket position and get it into place in the hands, like so. But there's no point doing it on this A pose. I'm going to click up the top left here where it says preview animation, and I'm going to change it to, where's our idle animations? Idle rifle hip. Nice. Hey, that's pretty good where it is. I know it's a little bit off with the hands, but remember this is a third person game and these animations are not set up to work with these assets, so it's never going to be perfect. I might just rotate it a little bit so that it's not clipping through the thumb there, like so. And I might also try a different preview animation, idle rifle iron sights. When we're aiming down the sights, yeah, see, so it's not perfect, but that'll have to do, just like that. That's fine. I can save that and close that, and then back in our character's blueprint with the weapons selected, I can up here choose the parent socket, and I'm going to choose the socket we just created, hand R socket. And then up here in the transform, I can hit these back arrows to reset these to the default. So I'm going to zero out the location and the rotation, and then we have our rifle there. And the scale looks to be correct there, so you don't want to change the scale on both. Basically the socket is scaling this down, so just to demonstrate, I might find my socket again, hand R socket, and what if I change this to 2, like so, and save it. In our character, yep, it scaled it up as well. So we're just going to scale it down in the socket because it means placing it with the preview here is just easier. So we're going to leave this relative scale in the socket as 0.8, 0.8, 0.8. Save that, and there we go. Actually, we shouldn't have this idle animation, should we? We should have a one where he's holding the weapon from the hip fire. So let's head over to our animation blueprint by browsing to it here and opening up ABP Mani if you haven't got it open already. And in locomotion and idle, I'm going to get rid of this idle, and I'm going to find idle rifle hip, plug it in there, make sure you check loop animation, and I'm also going to control C this and back out and go into my upper body anims and idle and delete this one and paste in my idle rifle hip fire there. Very good. Alrighty, let's set up some aiming logic, guys. So in our character's blueprint, in the event graph, I'm going to go down to the bottom here and I'm going to right click and find right mouse button, And I'm also going to create a variable here. I'm going to call it aiming, question mark. And I'm going to alt click and drag this out twice, because off of pressed right mouse button we're going to set this as true, and off of released we're going to set it as false. I'm also going to copy the character movement and this set max walk speed. I'm going to duplicate it down here, because when we aim I want to set my max walk speed to 150, and on that note, when I run I want to make sure that I'm not aiming, so I'm going to get my aiming variable here and a not boolean. So if we are not aiming, I'm going to use that as the condition on what we call a branch, and basically this branch is you run the execution pin into the branch, and then if these conditions are true it will execute true, and if it's false it will execute false. So the reason I've put not aiming and true is because it's best practice to have the bulk of your code running off of the true, and then if it's false it will just do nothing. So every time we press the left shift, if it's true that we're not aiming, then we'll be able to sprint. If we were aiming, it won't let us sprint, and if we aim it will also set the walk speed back down to our 150. So just to demonstrate this working, if I hit compile and save and I hit play, now if I press shift I will sprint, if I press right mouse button I will slow down, and if I'm holding right mouse button and I try to sprint, it won't work. I can only sprint if I'm not aiming. Nice, very good. Now with this aiming variable set up in our character's blueprint, we now need to pass it over to our animation blueprint to set up our aiming animations. So I'm just going to close the skeletal mesh and the skeleton here. We don't need those, and we don't need the assault rifle. In the animation blueprint, if we go to the event graph, remember this is where every time we update the animation we set these variables, and we need to set the is aiming variable, because we do not have that here in our animation blueprint. We only have it over in our character blueprint, so we need to use our reference to our character to grab it. But the problem here is with this basic animation blueprint from the template is that this is not a direct cast to the character that we're using. So we need to make a couple of changes here real quick. We're going to delete this cast to character, and off of get owning actor we're going to cast to third person character, cast to BP third person character. We're going to plug in the execution pins here and plug in as BP third person character to this set character reference. We're also going to select this character reference, and up here in the top right we're going to change the variable type to an object reference to our BP third person character. So BP third person character object reference. It's going to give you this warning here. Just click change variable type. It will do some things and stuff. You can close that, and now this is a reference directly to our character. So now we can drag off of character here, and we can get aiming question mark, and we can drag off of that and promote to variable, and we can leave it as aiming question mark. We can add an execution pin to this sequence and plug this in down here. So just to be clear, this aiming is the aiming that we set up in our third person character. We are using our reference to that character to get it, and then set another variable also called aiming within the animation blueprint. So this aiming and this aiming are actually different variables in different blueprints, but this one is set off of this one so that our animation blueprint knows if we're aiming and then can change the animations accordingly. By the way, sequence here is every time that the animation updates, it's going to play this sequence. So it's going to go boom, 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 and execute all of this code every time. Boom, 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 boom. Updates the animation, boom, 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 many times per second. So this is just always firing, and these are just always updating. Checking, checking, checking our ground speed. Should we move? Are we aiming? Blah, blah, blah. So now that we've got access to this aiming variable in our animation blueprint, we can head over to the anim graph, and the upper body anims is where we're going to be doing most of our work here, because we're doing the upper body animations without aiming. So we can go into upper body animations and idle, and the first thing we can do is alt click this, move this down here, our idle rifle hip, and we are going to find a node called blend poses by bool. Blend poses by boolean. And our aiming variable, we can control click drag this onto action value. The action value here is what's going to decide whether we blend the false pose or the true pose. So if is aiming is true, it's going to play a true pose here. I'm just going to plug in that output there. And we are going to find our idle rifle iron sights. Plug this in here and make sure with it selected we check loop animation. And now if I hit play, when I'm idle, I'm in the idle pose, and if I right click, I'm in the aim pose. And now we just need to set this up with our walking and running as well. So we've got it for idle, we just need to set it up for our walking and running. How we're going to do that is we are going to go into our retargeted UE5 anims, and we're going to find our blendspace dir move upper. I'm going to click it and control D to duplicate that and change the name to dir move upper aim. So this is going to be the one while we're aiming. If we open that up and have a look at the animations we've got here, they're all hip firing animations, so they're no good to us. What we can do is actually bin all the samples here in blend samples, all gone, very nice, and throw in some different stuff. So the first thing we can get is idle rifle iron sights, put that in down the bottom, and we will drag in two more and put them in the bottom right and the bottom left, just for safety's sake. And now we will find our walk forward rifle iron sights, put that in at about 150 and direction 0. Our walk left will go here, our walk right will go here, and walk backwards over here and also over here. Nice. And actually we don't need to put in jogging, so what we're going to do is because this causes errors if I leave these up here, I'm going to actually change the maximum axis value on the vertical, so on speed, to 150, because remember, when we're aiming, our max walk speed will be 150, and then I can just drag these up to the top here. I can save that and close that, and in the animation blueprint I'm going to back out to my upper body anims and go into walk run, and I'm also going to alt click this to disconnect it, move it down here. I can actually copy from idle, I can copy this blend spaces by bool and the aiming. I can just hit Control C and then go to my walk run and Control V that in there. The false pose will be my dir move upper, and my dir move upper aim will be my true pose, and I can plug in direction and speed from right here. Compile and save. And now if I hit play, I've got my walking and jogging and idle animations, and I can aim at any time. And when I aim, it's going to go into the aim pose. It's going to slow me down. Very cool. Alrighty, guys. Nice. Making very good progress here. I hope this is easy enough to follow. I've designed it in a way that it should be for pretty much any beginners to follow along and make this with me. So please stick around, because what we make in the end here is actually going to be pretty damn cool. Alrighty guys, what we're going to do next is make it so that our character can look up and down. And how we're going to do that is we're going to use the mouse input to rotate the spine bones of our character. Now, there are other ways of achieving this, such as with aim offsets, but we're not going to do it that way. We're just going to do it this way by rotating the spine bones of our character. It doesn't matter too much how you achieve stuff in video game development. What really matters is the result. So where we're going to be working is this section that says camera input. So in your BP third person character, find your camera input here, and we're going to start by creating a variable, calling it pitch, and we're going to change the type to float. Then we're going to alt click and drag this out into the event graph here and plug it into the end of our camera input here. And what we're going to be doing is using this action value y, which is the action value. It's basically a very small number that's put out every time you move the mouse up and down. And then this node here is taking that number and using it to calculate, moving the camera. So what we're going to do is take this value here. We can just click and drag off this reroute node, and the very first thing I'm going to do is just divide it by 2. This is just to dial down this number a little bit so that this rotation works in time with the camera. We're just dividing this value by 2, and then what we're doing is we are going to add to the pitch. So this is a cumulative. Every time you move the mouse up and down, it's adding to the pitch, but we don't want it to add infinitum. So the next thing we're going to do is find a clamp float, and we're going to clamp this value between 2 numbers here. So like I said, it's adding, but it will not add beyond whatever range you put in here. And the range we're going to put in here is -18 to 18, and then plug the return value into this set here. So every time we move the mouse up and down, we're setting the pitch, and what we're setting it as is what it currently is plus this action value clamped between these 2 values here. So with that done, we can hit compile and save and head back over to our animation blueprint and go to the event graph, and we need to now grab our pitch from our character's blueprint and set it in our animation blueprint. So what you can do down here is just double click on this line that comes off the character reference to get a reroute node, and then you can drag off of that and you can get pitch, the pitch that we've just created, and then promote to a variable also called pitch in the animation blueprint. So now we have access to the pitch variable in our animation blueprint. We can go over to our anim graph, and actually what we're going to do here while we're here is I'm just going to alt click to delete these connections, and I'm going to move this default slot down here between upper body anims and the blend poses 0. The reason for this is the slot that into which any animation montages that we play are inserted, and the animation montages that we're going to be using are mostly like sort of recoil animations, so we want them on the upper body. We don't want them to affect our legs and so on. So I'm going to move this here, And then I'm going to grab all of this and move it way out to the left, because in here is where we're going to insert the nodes that will rotate the spine bones of our character. So what we want to do is right click and find transform modify bone, transform modify bone, and then with this selected, you can see here there's 4 pins: alpha, translation, rotation, and scale. We will only be needing rotation. So what we can do to get rid of these other nodes is up here, we can click under translation on the pin and uncheck expose as pin. And rotation is the only one we will be needing, so we're going to leave that, but we're going to change the rotation mode to add to existing. Okay, and then scale, unexpose this as a pin, alpha, unexpose this as a pin. So you should just be left with this 1 pin rotation with the rotation mode set to add to existing. With that done, we're going to leave this selected and we're going to Control D and duplicate this 4 times because we're going to need 5 of these. We can plug in the executions here and you'll get this little interim node local to component will automatically be spawned. Just connect all these execution pins and once again you'll get this interim node component to local. I'm just going to select all of these and press Q on the keyboard to align them, and then down here I'm going to right click and find a make rotator, and I'm going to plug the return value into the rotation pin on each of these nodes like so. I also need to, I'm going to select the first transform modify bone and I'm going to change the bone to modify to spine 1. I'm going to select the second one and make it spine 2, third one spine 3, so on and so forth, spine 4 and spine 5. I am then going to take my pitch and plug it into X here. I know this says roll and this says pitch, but the pin that we actually need is X, so plug pitch into X. If I compile and save that and press play now, our character will be able to look up and down. So you can see this happening in real time. It's actually rotating the spine bones of our character to make them look up and down, and because we divided that action value Y by 2 and we clamped it between the values of -18 and +18, which by the way is 90 degrees divided by 5 because we're rotating 5 spine bones, we now have the ability to look up and down. Really cool. So this basically does the job of an aim offset 1D, which as I said is another method for making that kind of thing work, but this is how we're going to do it on this project. Alrighty, let's add some firing logic. So what we want to do is go back into our BP third person character. I'm going to find some empty space. I might put it below my aiming. So I've got my aiming here, and then I can right click, and what I'm going to do is find left mouse button. And off of left mouse button we're going to set a variable, so we're going to create a new variable here and we're going to call it can fire of type boolean, and we're going to alt click drag this out twice. Off of pressed we're going to set can fire as true, and off of release we're going to set it as false. We might change how this is set up later on, but this is just to get things going. Okay, so after we press the left mouse button and we set can fire to true, I'm also going to get can fire and off of it find a branch. So this is going to be the branch that dictates whether we can actually fire or not. What we can do is we can grab our weapon, and off of that I'm going to find play animation, and we're going to find our fire rifle W. Fire rifle W is the animation that comes with the weapons pack. So I can plug that in there. That's going to make our weapon actually fire with the muzzle flash and everything. And the next thing I'm going to do is check if we're aiming, because we are now going to, so aiming and branch, we are now going to insert our montages of our character firing, so their arms moving and whatnot. But first we need to just create those animation montages. So if we go to our UE5 retargeted anims, it should be, where have we got? Fire rifle hip and fire rifle iron sights. What we need to do is create some animation montages based on these animations. So right click on fire rifle hip and find create anim montage, and this says just added montage to the name, so I'm just going to leave it as that, fire rifle hip montage. I'm going to open that up and change a couple of settings here. I'm just going to pause this so it's not as annoying. I am going to change the blend out trigger time to 0.01, and that should be all I need to do in here. Otherwise this animation will blend out basically before it's even started. It's a very short animation, so it's only 7 frames long, so we need to not trigger this blend out too early, so just change that to 0.01. I think that's all we should need to do in there. We're also going to right click on fire rifle iron sights and create an animation montage. Leave the name how it is, open it up, change the blend out trigger time to 0.01, save and close that, and then back in our blueprint here, what we're going to do off of true is find this play anim montage, or actually just play montage. Play montage is the one we need. We can actually duplicate that and also plug one into false. So remember, off is aiming here, so this one will be our aiming and this one will be our hip fire. You can grab your mesh here, mesh, plug it into in skeletal mesh component. So that's the skeletal mesh in which the montage is going to play, and here should only have 2 montages in your project, so this will be your iron sights and this will be your hip fire. Nice. So what we're going to do is we're going to set this assault rifle up to fire in fully automatic, and how we're going to do that is off the execution pin here we're going to find a delay, and we're just going to delay by 0.1, and we're going to plug both of these into the delay. And what this is going to do is basically when this node is triggered, it just pauses for 0.1 seconds and then starts executing again. So this is just a very simple way of setting up a fully automatic system. Before I loop this back, because I'm going to loop this back to here, I'm going to create what's called a custom event. So just down here, I'm going to right click and I'm going to search for add custom event, and I'm going to call this line trace. Line tracing is what we're going to do to actually detect our hits with our bullets and so on. So this custom event that I've just created, I can then call anywhere else in the blueprint. So I could call it here. I could just type line trace and call this function line trace, and then whenever I release the left mouse button, it's going to fire off whatever I put on the end here on line trace on my custom event. I'm not going to put it there. What I'm going to do is I'm going to put it after the delay here. Actually it should be before the delay. My mistake. what I'm going to do is put it here, and then I'm going to delay, and after the delay I'm going to circle back to this can fire branch here. I'm going to double click on this to get some reroute nodes, and I'm going to put this over the top here, so that I'm just going to move that up a bit so it's less cluttered. So here, just to walk through this again, when we press the left mouse button we set can fire as true, we check if can fire is true, and then we're going to play an animation on our weapon. We're going to check if we're aiming. If we are aiming, we're going to play a montage on our character where they're aiming down the sights and got some recoil, and if they're not aiming it's going to be a hip fire montage. We're going to trigger this line trace, which we are going to set up in a moment, which is going to be our bullets, and then we're going to delay for 0.1 of a second and come back around, and again, if we haven't released the left mouse button, this will be true and it will keep on firing. If we do release the left mouse button, it's going to trigger false and it's going to break this loop so that it's not an infinite loop. Let's just, for funsies, hit play and have a look what that looks like. So you can see here we've got the arms are moving a little bit to the fire. Same with aiming. We can look up and down. Nice. Very nice. If I just hold fire and then press F8 to eject, what we can do is look at our character, and we can see a little bit of jumping here from the montage that's playing over and over again. Very nice. Alright, let's set up our line trace logic. So what we need off of the end of this, off the beginning of this line trace custom event, is a node called line trace by channel. Line trace by channel. This has a start point and an end point. The start point is actually, in our third person shooter, we want to be the barrel of our weapon. So what we're going to do is click on a weapon up here and then browse to our skeletal mesh asset by clicking this browse icon, open up our assault rifle, and then clicking on the skeleton up here. So we actually want the skeleton of our assault rifle. Here we have the skeleton. You can see it's got bones such as the the trigger moves, and a couple of other little parts move as it fires. What we're going to do is click on the root bone here and right click and add a socket. So just like when we added a socket to our player character's skeleton to attach the assault rifle to, I'm going to add a socket here, and I'm going to use its location to draw our line trace for our bullets. I'm going to click on the socket, press F2 and just rename it to barrel. It's important that you remember exactly what this is called, so I'm just going to call it all lowercase barrel. I'm also going to double click on there to select it and Control C to copy, so I have the name copied. And with the barrel selected, I'm going to press W in the viewport, and I'm going to move this location to the end of the barrel here. This doesn't have to be 100% accurate. It'd be good if it's just, a couple of millimeters in front of the barrel, 1 millimeter in front of the barrel, and roughly in the center of the barrel there at the front. Nice. So this is going to be where our bullets are coming from. We can save that and close that. We do not need to do anything else in there, and we do not need that. And what we're going to do now is grab our weapon, drag it out here, and then I am going to do get socket, whoops, definitely spelled that wrong, get socket location. So this is the location of that barrel socket, and in socket name we can just paste or type in the name of our socket we've created, barrel, and that will be the start location of our line trace. The end location is a little bit trickier. We're going to use our camera. So we want the bullets to go towards the center of the camera. So wherever the center of the camera is pointing, right there, that's where our bullets will go. There's different ways of setting this up. I'm not going to make this too complicated, but we do want some nice results. So I'm going to keep it as simple as possible with some very cool results. So we're going to grab our follow camera here. And off of follow camera, what we can do is get world location. And we're going to get the end point, we need to not just get the location, but we need to get where it's pointing. So also off of follow camera, we're going to get world rotation. And off of get world rotation, we can get forward vector. And we're going to end up adding these together. But what we're going to do first is just multiply this by a very large number. I'm going to right click on this pin and change it to a float, single precision, and I'm going to change the number to 15,000, which is 150 meters. So that's going to be the end point of our line trace. I am then going to add these together. Add. Plug that into the end point here. And now, every time I fire, I should get a line trace. Its debug is still set to invisible. And another thing that's making it invisible, so draw debug type, we can change to for duration. And it just means it's going to draw a line that represents the line trace for 5 seconds, and then it will disappear. But the other thing that's making it hard to see is our camera is kind of right behind our player, like this. This doesn't look great for a third-person shooter, so let's change that now. What we can do is select the camera boom here, camera boom. We're going to change the target arm length to 300, so make it a bit shorter. And then the socket offset here, what we might do is make this 75 and 50. Let's try that. And while we're here, let's do some nice lag so that the camera's a bit smoother. So if with the camera boom selected, if you search for lag, you'll see camera lag and camera rotation lag. Let's enable both of these, and let's just leave the lag speed and the rotation lag speed as 10 for now and see how that plays. So now you can see our camera is over to the right a little bit and a little bit higher and a little bit closer. This is a much nicer camera. And now if I fire, it's drawing a line trace between the end of the barrel and wherever the center of the camera is pointing. Nice, but this is a little bit too accurate, especially for hip firing. So let's add some randomness to our line trace here. Now this is where things get pretty cool. What I'm going to do is go into our third person character here. I am going to, I'll just disconnect this, grab all of this and move it up here. I'm going to duplicate it and have it down here. And then off of line trace, I am going to make a branch and I'm going to check is aiming. If we are aiming, we're going to play this one. If we're not aiming, we're going to draw this one. So we can have some different randomness here for aiming and not aiming. And all we want to do is when we add the end point basically to our start point to find the end of our line trace, we can just add a pin here and then right click on it and split struct pin. So this is just splitting the X, the Y, and the Z, so we can plug in different things here. And what we're going to plug in is a random float in range. Random float in range. So every time the line trace is drawn, this node is going to spit out a random number within this range. And let's just make it minus 100 to 100 for the aiming. And we're actually going to need to duplicate this twice, so Control D to duplicate it twice and plug into each of these pins here. And I will also duplicate it down here, add this pin, right click, split struct pin, and for the hip firing, let's make it minus 250 to 250. Minus 250 to 250. Duplicate that 2 times. Plug these in right here. Compile and save. If we hit play now, while we're aiming, got a little bit of spread there, and when we're hip firing, we've got a bit more. I think we could probably use a bit more hip fire spread than that. I also think that the rotation lag needs to be sped right up. It's not very responsive for aiming. The camera lag in general, which is what will make the movement of the camera lag to try and keep up with the character, I think that looks okay. The character moves around on the screen a little bit now when we move. Feels quite nice. What we might do is select the camera boom, and with lag searched, we'll change the rotation lag speed to 15. And let's just try that. That's much better. It could even go up a little bit higher than that. So let's make it 20. Call it a day. And let's add a bit more spread to our hip fire, hey? Let's make this minus 350 to 350. Whoops. Minus 350 to 350. Nice. Decent. Very cool stuff, guys. Alright, what's next? Let's implement some ammo system. So we'll go back to our BP third person character, and in the firing logic here, I'm just going to grab the delay in this reroute node and move them out a bit. So we're going to add some stuff in here. Let's create a new variable and call it ammo of type integer. And I'm going to duplicate that, and I'm going to call this other one max ammo of type integer. I'm going to compile so that I can change the default value over here, and I'm going to change the default value of max ammo to 40, and I'm also going to change the default value of ammo to 40, and I'm going to get the ammo, and I'm going to find what's called a decrement int. So basically, this, each time it's fired, just minuses 1 off of the ammo. So each time we fire, it's going to minus 1 off this ammo. And I'm also going to go back to this branch on the can fire, and I'm going to drag off of the condition and find what's called an AND boolean. So this means that every condition connected here has to be true for it to be able to fire. So I'm going to grab my ammo, and I'm going to check if it's greater than 0. So if we can fire and the ammo is greater than 0, then it will continue to fire. And what we can do to check if this is working is we can grab a print string, and I'm just going to plug this output here into the print string, so it's going to print how much ammo we have. If I press fire now, you can see up the top left it's updating, and if it gets to 0, we can't fire anymore. Very good, so that's working. We can also create a reload mechanic, so I'm going to just grab this line trace stuff and move it down, and I will find the R key. Where is it? Where's the R key? Might have to scroll down to find this. I don't know why it's so difficult, but here we go. R. And actually what I'm going to do is I'm going to create a variable called isReloading ? This is going to be a boolean, and off of pressed I'm going to set isReloading as true, and then I'm going to set my ammo as my max ammo here. So the reason I've made this a variable is so that you can change it at any time. You can just change max ammo here, and then when you reload, it will set the ammo as max ammo here. But we don't want to just print this to string every time. So instead what we're going to do is create a HUD so that it displays on screen. So I'm just going to delete that print string and plug that back in there. And to keep things organized, what I might do in content is right click and create a new folder. I'm going to call this _main. The underscore is just to make it appear at the top here. And in main, I'm going to create another folder and call it HUD. And within HUD, I'm going to right click and create a, I'm going to find user interface here and widget blueprint. So a widget is what displays on the screen. You can just click user widget, and I'm just going to call this UI _ main as well. Open this up. And so this is where we design our HUD. The first thing I'm going to look for in the palette up here is a canvas panel. You can grab the canvas panel and just drag it out here, and now this is your canvas onto which you paint your HUD. I'm going to also grab text here, and I can drag it onto canvas panel, and then I'm going to grab this text and I'm going to move it to about where I want my text to be, down here. With it selected, you'll see this thing pop up. This is an anchor. So this, if you are displaying your game on different displays, say with different resolutions, this will help to anchor your this information to wherever you want it. So I'm going to pull this down to the bottom left here, and then I am going to grab this and move it up to here, and grab this and move it out to here, and then you'll see it's basically anchoring down to this bottom right corner here. I'm going to, over here in the details panel, I'm going to change my text block to capital XX, and this is just to denote a a two character. There's going to be 2 digits here, my ammunition. I'm also in font. I'm going to make it a bit bigger, call it size 48, and in outline settings here, I'm going to choose outline size 2, and that should be fine for now. I am also going to click on this and Control D to duplicate it. I'm going to move this over here, and I'm just going to change this to a / and make the font say 60, and I'm going to move that up. It's there, and I'm also going to duplicate this one more time, and I'm going to find an infinite symbol. I don't actually know how to type in the symbol here. So what I'm going to do off screen here is I'm just Googling infinite symbol, and then you'll quickly find the infinity symbol in text. I can Control C and copy that. I'm going to paste that in there and hit enter. And I'm also going to make that 60. Whoops, grab the wrong one here. And I'm going to move that there, like so. Now we need to bind this to our ammo count in the game. So what we need to do over here on text is click bind and create binding. And then here what we're going to do is cast to our player character, which is the third person character, cast to BP third person character. This object here is very important because although you think you're casting to a specific thing here, you can actually have multiple BP third person characters, so you need to know which one. And the best way is just to get player pawn. The player index is 0, so this knows which one we're casting to, and as BP third person character we're going to get our ammo, and then we'll need to convert this. Let's see if it does it automatically. It does. You can just plug it in and it converts it to text and integer, and that's all we need to do in here. So we can actually save and close our UI main, but now we need to add it to the viewport. And how we're going to do that is we're going to find our event begin play up here, create some more space over here, and we're going to drag off of the end and create widget. We're going to select the widget we just created, which is our UI main, and we are also going to add to viewport here, add to viewport. Now if I compile and save and I hit play, I've got my ammo count down the bottom right. If I fire, it goes down. If it gets to 0, I shouldn't be able to fire anymore. I press R to reload and it goes back to 40. But we don't want to just be able to reset it to 40 like that. We want some animations. So let's get to work on that. So we're going to be working down here where we press R, our reloading animation. Actually, what we want to do is find our retargeted animations, our retargeted UE5 animations, and let's grab, where is it? It's called Reload Rifle Iron Sights. Actually, Reload Rifle Hip will do the trick. So Reload Rifle Hip, we're going to right click on that and create an anim montage. We can leave the name the same, open this up, and you can see here we've got a nice little reload montage. We're just going to change the blend out trigger time to 0.05. That should be fine like that, and close that. That's all we need to do in there. And then here we are going to actually set our ammo to 0. No, sorry, we're not going to do that. Sorry, a bit of a brain fart here, but I am working up to something pretty cool. Let's just play animation montage, or just play montage. It will just be play montage. And grab our mesh, plug it into in skeletal mesh component, select the montage, which is our reload rifle hip montage. Very good. And we can also play animation on our weapon here. If we drag in weapon, drag off of weapon, and play animation, we can find our reload rifle. Reload rifle iron sights. Reload rifle iron sights. We can grab that one, and we're also going to hit browse to this one and open it up. because this is the actual one where we're going to insert some anim notifies. So you can see this one already comes with some nice little sounds here. We might just want to, I'm going to drag this onto this track. It doesn't need its own track. We'll use this other track here for our new anim notifies. So I'm just going to move this here for timing. So you can play around with this to make sure the sounds are playing right when you think they should. This one is also a little bit early. Let's just move it there. Very good. Now before we add some anim notifies here, we have to create them. But just quickly, I'll explain what they are. Anim notifiers are basically something that when an animation gets to a certain point, say you set this one right here, this one's playing a sound, but we could also make one that executes some code. So what we're going to do is right here in this folder, we can right click and create blueprint class. And down here, drop down this all classes and search for anim notify. This one here, anim notify. There's also anim notify state. We're just going to be using anim notifies today. So anim notify, select, and let's call this anim, anim n underscore remove clip. Okay, and we will also duplicate that one, and we'll call the other one insert clip. Alrighty, so now that those are created, what we can do is we can add them here to this second track. I'm going to right click here, add notify, remove clip, and that's going to line up with that one there. And I'm also going to add a notify here, insert clip, and line it up with there. So when the clip is pulled out, actually those can come back ever so slightly. And then when the clip is inserted, it's going to anim notify insert clip. And what we're going to do, we can close this now, save it and close it. What we're going to do is open up anim notify remove clip, and up here in functions we can click override received notify. So this is the code that's going to execute once the anim notify has been received. What we're going to do is cast to our BP third person character. Object will be get player pawn, and as BP third person character we are going to set ammo as 0. Very good. We can compile and save that, and actually what I'm going to do is grab these 3 nodes and hit Control C to copy. I'm going to close that one, open up insert clip, and in insert clip you might have to click open full blueprint editor here if it's not showing the usual screen. Click on override here on functions, received notify, make some space here, paste in what we copied, and here we're just going to set the ammo as max ammo. So we get max ammo, and we can plug that into as BP third person character here. Set ammo as max ammo once we insert the clip. Now this is pretty cool. These animations actually work very, very well together. And so we don't actually need this anymore. We're not going to set it as max ammo here. It's going to do it via the anim notify within this reload rifle animation. But what we're going to do is just put a delay here of 2 seconds, and then after 2 seconds we're going to set is reloading as false, and we're going to use this boolean to stop our player from firing. We're also going to set can fire as false here at the start. Set can fire as false, and the reason for that is if they're already firing on fully automatic, we just want to interrupt it here, and then while they're reloading, it's going to be set as reloading, set to false after this delay of 2 seconds. And in our firing logic on the AND boolean here, I'm just going to add one more pin, and I'm going to get is reloading and a not boolean. So as long as we can fire, our ammo is more than 0, and we're not reloading, then we can continue to fire. Nice, very good. Now this should all work. If I hit play, I can fire. If I hit reload, these animations line up very nicely, just as it turns out. And if I mash fire, I won't be able to fire again until the reloading animation is complete. Nice, works very well. Alrighty, now I'm going to do something with you guys that no one would put in a beginner's tutorial. I'm going to add some zoom when we right click and aim, and it's going to work very smooth and very nice, and it's going to be using something called a timeline, which now's a good time to introduce you to. So what we're going to do is we're going to do this on the right mouse button logic here. So when we aim, we're going to zoom in, and also while I'm here and I'm reminded of the max walk speed, what we might do is a nice little toggle on the max walk speed, but we'll add that in later. So right now what we're going to do is we are going to set the offset on our camera boom. So we can grab our camera boom here and we can get socket offset, and the socket offset, if you need reminding, just click on the camera boom here, and the socket offset is what we changed this stuff to here, to get the over the shoulder action. Actually what we're going to do is we're going to grab a timeline sequence here, a sequence, and we're going to add one pin, and we're going to duplicate that, and we're also going to have this sequence running off at the bottom here. I'm going to grab all this stuff and move it way out to the side, because we're going to add a bunch of stuff here. So off of 2, so basically every time this is pressed and this stuff has executed and then we get to the sequence, it's going to go boom, 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 and execute this sequence in order. Every time you click the right mouse button, it's going to go boom, 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 execute this sequence. The first thing we're going to do off then 2 is add a timeline. Whoops, if I can spell timeline correctly. Add timeline, and let's just call this weapon zoom in. Okay, we're also going to do the same off then 2 down here, add a timeline, and we'll call this one weapon zoom out. It's not exactly what it is, but that'll do. Now every time that we do this, we click the right mouse button. The first thing we want to happen off this sequence is stop the other timeline from zooming in or zooming out. The reason is we don't want this timeline to continue. If we press the right mouse button very quickly, we don't want the other timeline to continue. So the first thing on the sequence is to stop the other timeline. And actually, before I forget, 2 actually needs to be plugged into play from start. Play from start, not play. So we're going to hold control, click and drag that onto play from start. what we want to happen in between here on 1 is to update the current socket offset. Okay, so I'm actually going to put this here, and I'm just going to put it out to the top here. So I am going to drag off of my camera boom, and I'm going to set the offset, set socket offset. I'm going to duplicate that down here, plug the target into camera boom, and then these are going to set off of 1. And what they're going to set as is just the current socket offset. So we've gotten our socket offset here from the camera boom, and we're just setting it as what it is. But the reason we're doing this is so that we have a start point for our timeline. Now, timelines, you'll get a better idea of how they work in a moment. I'm just going to right click here and split the struct pin on both of these, because we're going to use just the X here to move our socket offset forward. What we're going to do is we're going to double click on weapon zoom in, okay, and we're going to add a new track here, add float track. Now this is basically a timeline here, and this is time over here, so we can set the length. We can just leave it as new track 0. We don't need to rename it, but I'm going to change the length here to 1/4 of a second, 0.25. Then what I'm going to do is hold shift and click twice on the graph here, and it's going to insert these 2 points. I'm going to select the first one, and I'm going to change its time to 0 and its value to 0. And then I'm going to click on the second one, and I'm going to change the time to the maximum, 0.25, and the value to 100. Okay, I can click these icons here to fit it to the screen, and I can use the mouse wheel to zoom out a bit, and I'm going to select both of these points, and I'm going to right click and just select auto, and you'll see that when I do, it'll change this straight line to a nice and curved one. So basically, when this timeline plays, it will play over time, and it will spit out whatever value this is here. So see, it's 30, 40, 50, 60, 70, 80, 90, up to 100 with this nice curve here. So it's a nice smooth transition. We can save that and close that, and we are going to do basically the same on the other one. We're going to add a new float track, change the time to 0.25, whoops, 0.25, shift and click 2 points, but this time the first one at time 0 will be of value 100, and the second one at time 0.25 will be of value 0. I'm going to fit these to the screen, zoom out a bit, select both, right click and check auto. Now this timeline is going from 100 down to 0. Okay, very good. I can close that now. So basically every time these timelines update, they're going to set our socket offset for us. So we can actually duplicate these ones and plug them into update. The target will be the camera boom, so we can grab the camera boom, drop it in the middle here, and plug it into both of these targets. And we're going to right click on the socket offset here and split the struct pins, and we only want to change the X. What we want to set the Y and Z to is what they already are. So if you click on your camera boom here, you can check your socket offset. 0, 75, 50 is the default. So we're going to change the Y and the Z to 75 and 50 on both of these, so that these aren't changing. And Now we want a little node called map range clamped. Map range clamped. What this does, if we plug the track into value here, it takes the value that the timeline outputs. So remember, this one's going from 0 up to 100. It will take that value and it will convert it to a different range here. So that if I put in range A and in range B as 0 and 100, because remember this timeline is going from 0 up to 100. If we take a look at it, 0 to 100. So this will take whatever it is in that range and output it as this range. And what we want the out range A to be is whatever our socket offset is at the time, and the out range B that we want is what we want to set it to. So I'm going to change it to 200, so it's going to bring our camera 2 meters forward. Plug this return value into the socket offset X, which is what we're changing. We can grab this one and duplicate it down here, plug the value into new track 0. Remember, this timeline goes from 100 down to 0. So I'm going to change the in range from 100 down to 0. I am going to grab the current socket offset here and make that the out range A. And what we want to change it to here is back to 0. Because remember, our default is 0 here. I can plug this into the socket offset X. Now, this looks very complicated and this might be a little bit overwhelming, but I'm sure you can follow along, and this is just a good little introduction to timelines. So we've got a timeline that's playing when we right click or release the right click. It's outputting a number. This map range clamped is converting that number from 0 to 100 to whatever the actual socket offset is when you release or click the right mouse button. Whatever it is at that time is going to be the start point, and the end point is whatever we want to set it to, 200, and then in the reverse back to 0. So this is handy for camera work. This helps to make smooth transitions. Timelines plus map range clamped equals smooth transition. So if I hit compile and save now, hopefully this works. Nice. We've got very smooth little zooming action. Boom. Zooming in. Very nice. Reloading. Stuff's coming along really nicely. I've got a nice little touch we can add here. Let's add some bullet casing ejecting from our weapon here. Bullet casings ejecting from our weapon, and then they'll scatter all over the floor. Really cool little thing that we can do. Where we're going to be doing this is in our firing logic here. I will just anywhere here before the delay, so every time we fire it's going to do it right here. What we need to do first is in our weapons folder we need to find the casing, which here you can find assault rifle B ammo. If you open this up, you'll see this is some 7.62 or something casing. The only thing we need to do in here, this asset is what's called a static mesh, so it doesn't have any moving parts. It's literally just a 3D model. But what we need to do up here is click collision and add box simplified collision, and you'll see this box has appeared over it. Now this has a very simple box collision here. You can actually make it, if I go remove collision, we'll remove that. We can actually add a we'll add a capsule collision, because it is round. You do probably want it to roll around on the floor, so add capsule simplified collision. That's all we need to do in here. We can save that and close that. And then in here, what I'm going to do is I'm going to click on that one to get the name, Control C to copy that, and I'm going to right click and create a blueprint class of type actor, and then I'm going to paste the name of that ammo in and just add underscore BP to the end. And the reason I've named it that way is just so that it's organized here. It's grouped up with the assault rifle here. I can open up this blueprint class, and over here in the components tab, I'm going to add a static mesh component. I'm going to call the static mesh component bullet casing, and then I'm going to click it and I'm going to drag it onto the scene root and replace the root. So now the root is this static mesh, and over here in the details panel I can change the static mesh to our, if I just search ammo, assault rifle B ammo, there we go. We've got this. This is now a blueprint, and the only thing in it is this static mesh. And as you remember, we just added collision to this static mesh, but we also needed to simulate physics. So if we search up here, or you can just find it here, simulate physics, we're going to check simulate physics. We're also going to go to the event graph, and on event begin play here, we're going to add a delay, and this is however long you want the bullet casing to stick around for before it disappears. I'm going to put 30 for 30 seconds, and then I'm going to destroy actor like so. One other thing we need to do while we're here is we need to check the collision. So if you just search for collision, you'll find this collision presets. Okay, it's set to physics actor, which has block all basically. We're going to change this to custom, and we're going to make sure that it ignores the camera, and we're also going to make sure that it ignores the pawn. Okay, this just, we don't want our bullets to like bounce off our camera or make our camera like clip because of where the bullet casings are coming in. So yeah, we just get rid of those collisions. I believe that's all we need to do in here. And now what we're going to do in our third person character, in our firing logic here, is we're going to spawn that bullet casing blueprint. So we can spawn actor from class, and I can search ammo, find our assault rifle B ammo BP. Also, if you open up the assault rifle B skeleton, you'll see that we've got a socket here called ammo eject. Ammo eject. So whoever made this asset was nice enough to put a socket here where we could spawn our bullet casings from. And I believe this slide comes back and forth as the gun fires in the animation. I'm going to select the ammo eject socket and press W, and I'm just going to move it out to just about here. Okay. I am going to save that and close that. Now wait, just before I close it, I want to point out that this points this way, right? So this is going to be good for our spawning the casing, but we want it to eject out to the right. So I'm just going to point that out now before we implement this logic. Spawn transform, what we can do is get our weapon, and we can get a socket location, and what we're going to do is we're going to copy the name of that socket. I can press F2 to rename, Control C to copy it, and we're going to paste it into the in socket name here. and spawn transform, we can just plug that straight in there. Actually, what we might do is I'm going to split this struct pin, and the location will go into location, and then we're going to get socket rotation, and again paste the socket name in here. The spawn transform will be the rotation here, and then what we want to do is add a little impulse to this bullet so that it spits out to the side of the gun. So off of return value here, which by the way is the ammo blueprint, is the return value here, we are going to add an impulse on the bullet casing. Add an impulse on the bullet casing. Plug in the execution pins here, and you want to select velocity change, check velocity change. What we're going to do on the socket rotation here is get the right vector. So as I pointed out before, it's pointing this way towards the front of the gun. We want to get the right vector that's pointing out to the right. Get the right vector, and we're going to multiply that. Right click on the pin and change it to float single precision, and we just multiply this by how much force we want in that direction. So multiply it by 100, plug that into impulse, compile and save. If I hit play now, I got bullet casings spitting out to the right. Very nice. They run out. I can't fire. Gotta reload. Nice. Coming together very nicely indeed. Alright, what do you say we add an enemy to our project? Alrighty guys, we're going to get our character and its animations from a website called Mixamo. It's totally free to use. And it has a whole bunch of characters and animations to choose from. So if you've never used it before, just sign up, log in. It's really not very hard, and it's totally free to use. And we're going to search in characters for zombie, and I'm going to grab this war zombie F Pedroso. This guy here looks quite nice. I'm going to hit download and leave it on FBX binary and T-pose. Hit download. And once that's downloaded, I'm going to find some animations for this guy. I am going to look for Old Man Idle and get this Old Man Idle because I think it looks quite good on a zombie character as an idol. Very good. I am going to hit download. I am going to select without skin because we already got the character. We don't need to download it again. I am going to change keyframe reduction to uniform and leave it on 30 frames per second. Hit download. And I'm also going to find Old Man Walk. This one here, Old Man Walk, I think it's also quite good. Little zombie walk here. I'm going to check in place to make sure that he's walking in place like so. I'm going to hit download. Without skin, uniform keyframe reduction, 30 frames per second. Hit download. And there's also a run that I like. I believe it's run forward. But it looks very zombie-like here, run forward, where he's kind of flailing his arms around. I'm going to check in place. And if I look closely, you'll see that the left hand is clipping through his leg there. So I'm going to change the character arm space to about 65. So it's not clipping through his leg there. Make sure in place is checked and hit download. Without skin, uniform keyframe reduction, 30 frames per second, hit download. And then I'm going to head on back to the editor. Just in my characters folder here, I'm going to right click and create a new folder and call it zombie. And in zombie, I'm going to right click, create a new folder, call it mesh, and another new folder called animation. I'm going to go into mesh and I'm going to right click and import and find the character, the folder where I downloaded the character to, and I'm going to select the mesh, which is War Zombie F Pedreso, and hit open. I can leave all this as default and hit import all. You might get this error about smoothing groups. It doesn't matter too much. I'm going to back out to zombie and go into animation, right click and import again. I'm going to select my 3 animations, hit open, and make sure that I select the skeleton, which is going to be War Zombie F Pedroso skeleton. Hit import all. And now I've got a character and a few animations to work with. Nice. I'm going to close that, and I'm going to close ABP Many as well. And now what we're going to do, guys, is we're going to create a character blueprint and an animation blueprint for that character from scratch. Now you guys have been introduced to this stuff a little bit earlier on in the shoot, but I really don't see any reason why I can't walk you through this. It's really not hard once you know how. So in zombie, what I'm going to do is I'm going to right click and create a new blueprint class, and I'm going to choose the type character, and I'm going to call it BP underscore zombie. I'm going to open this up, and straight away it has the bare bones of what we need for a character. I'm going to select the mesh here, and I'm going to change the skeletal mesh asset to our zombie. I am going to change his scale here with this little padlock thing closed. I'm going to change the scale to 0.9 because I happen to know that he's a little bit big. With grid snapping switched on to 10 units, I'm going to bring him down to about there, 90. I am also going to turn rotation snapping on and rotate him 90 degrees so he's facing the same direction as this arrow. I'm going to select the capsule component, and I'm going to change the capsule half height to 100 and the capsule radius to say 50. They'll be fine for now. We just need to get this guy animated. So let's also go into animation and right click and find animation blueprint, and make sure you select the correct skeleton, which is War Zombie F Pedroso skeleton. Hit create, and I'm going to call this ABP underscore zombie. I'm going to open that up and head straight over to the event graph, and this is where we're going to create, as you remember from earlier, the code that checks the variables in our zombie blueprint, so it knows what animations to play at any given time. So I'm going to right click up here, and I'm going to find a node called event blueprint begin play. I'm also going to get this try get pawn owner and drag off of that and find an is valid, this one here. Also going to drag off of try get pawn owner and cast to my BP zombie. And as BP zombie, I'm going to promote to a variable, and I'm just going to call it zombie. This is a reference to our zombie character, just call it zombie. And off of zombie, I'm going to get the character movement. You might have to scroll down to the bottom to find this one. Get character movement, promote that to a variable, call it character movement, plug it in here. On event blueprint update animation here, I'm going to get my zombie reference. I'm going to check is valid, and if it is valid, it's going to run a sequence. And I believe we only really need 2 here. We might even get away with just 1, because for now all I want is his ground speed. to animate his idle, walk, or run animations. So off of zombie, I'm going to get velocity. You might have to scroll down, find this one, get velocity. I'm going to promote that to a variable, call it velocity. Plug it into the first execution pin here. Then off of get velocity, I'm going to find the vector length xy. So this is the vector length of his velocity, but only on the x and y axes. And this is going to be our ground speed. Plug that into the second execution pin. And that should be good for now, just ground speed. He's not going to be able to jump or anything. He's a zombie, proper zombie. I'm going to go to the anim graph here, and I'm going to right click and add a new state machine. I'm going to click on it and just call it locomotion. Plug it into the output pose and then double click on it to go in, and off of entry I'm going to add a state and call it idle / walk / run. I'm going to double click on that to enter that, and then we need to create a blend space really quick. So very quickly I'm just going to check the max walk speed of our character. So I'm going to go into BP zombie, click on character movement, and over here look for max walk speed. It's 600. So I am going to go into the folder, the animation folder. I'm going to right click animation, down in legacy we're going to make a blend space 1D. Select the correct skeleton, and I'm going to call this blend space underscore idle walk run. I'm going to go in here, and in horizontal axis I'm going to change the name to speed and the maximum axis value to 600, and I'm also going to check snap to grid. I'm going to grab my old man idle and drag it over to the left here. I'm going to grab old man walk, put it on this first grid division here, and run forward I'm going to put over at the end here. And I can hold control and hover the mouse over this graph to see what the blends look like. Very nice. Okay, I can save that and close that, and in ABP zombie, in locomotion and idle walk run state, I'm going to drag in my blend space and plug ground speed into speed. Hit compile, and straight away you can see that our character is animated here. The last thing we need to do to apply this is go into the blueprint, select the, we can just select the root and change the anim class to our ABP zombie. And there we go. We have an animated zombie. What we might do is just drag this zombie blueprint out into the world, and he's hovering over the ground there, but we'll just see what it looks like during play. Yep, he's hovering, so we need to fix that. It looks like he needs to come down about 10 clicks. So let's, yep, he's way over the bottom of the capsule component here. So let's, with grid snapping switched on and to 10 units, let's bring him down 10 clicks. See how that looks now. Still hovering. Another 5 should do it. So I'm going to change this to 5. Bring him down 5 more. And that should be fine like that. Nice. Let's make it so our line traces can interact with this zombie here. So what we're going to do is click up the top right, settings and project settings, and we're going to search for channel, and you should be able to find, let's search line trace channel. It's going to be trace channel. Search for trace channel, and you got trace channels here. We can add a new trace channel, and let's just call it projectile, and default response is block. Hit accept. So we've added this new trace channel. And basically, this is the channel we're going to put our line traces on so that we can control what they do and do not interact with. So in our BP third person character, you can find your line trace logic, and we might have to compile this first, and then in trace channel we can choose projectile, trace channel projectile. And what we want to do in our BP zombie is click on the capsule component and search for collision. And in the collision presets, you'll see that this is blocking projectile. So we don't actually want the line trace to hit the capsule component. We want it to interact with the mesh itself. So we can change this to custom and ignore projectile. Okay. We can then select the mesh with collision still searched and collision presets here, and you can see it's on block for projectile, so we don't need to change anything in here for now. If I hit compile and save, now you can see that our line traces are interacting with the mesh by these little squares that you can see, and the change in line color on the line trace. You can see that we're actually hitting him now. Nice. Let's do something a bit fun with this guy and just make him ragdoll when his health reaches 0. It's not too hard to set up. In BP zombie, in the event graph, what we're going to do is create a couple of variables. I can call one health of type float, and I'm going to duplicate that one and call the other one max health. Max health. If we compile so we can set the default values of these, I might set the default value of max health to 150. He's a hearty zombie. And the default value of health as well to 150. Okay. Actually, what we need to do in our third person character is we need to do something with our line traces here. So the first thing I'm going to do is drag off of return value and find a branch. And this basically means that we're going to do this on both here. This basically means that we're only going to do something if we've actually hit something. Okay. We can drag off of out hit here and choose break hit result. And this is basically all of the data that we get from our hit. So on the other one as well, drag off of out hit and select break hit result. And we're looking for hit actor here. So we've hit an actor, and when we hit the actor, what we want to do is apply damage. Now this is built into Unreal. It's just a damage thing. It's to pass basically a figure over to something, and then you can use it to change its health, blah blah blah. But so this is what we're going to be using. So off of hit actor, apply damage. And the base damage, what we can do, just in case we want to change how much damage we can inflict on the zombies later on, is we can create a variable, just call it damage, damage of type float, compile so that we can change the default value, and we'll change the default value to say 20. And then we'll plug damage into base damage, like so. Nice. So now if we hit the zombie, it will apply damage to him. Sorry, excuse me. If we go over to BP zombie, we can find a node called event any damage. Any damage is caused to the zombie. This number will be passed over from the line trace. And what we can do is we can set the health. So we can set the health when he receives damage. We can set the health as the health minus the damage. So every time he gets damaged, we're going to set the health as what the health is minus whatever the damage is. Boom. And we want to make sure that his health is above 0. So we only want to do this if our health is greater than 0. So we can make a branch based on that condition. If his health is greater than 0, then set the health as health minus. So basically, if he's already dead, it's not going to keep changing his health. We don't need to execute the code here. And then we can also do basically the same thing. After we set the health, we want to check if the health is less than 0. So if the health is less or equal to 0, we'll create another branch here. So if the health is less or equal to 0, he's going to die. So we might just make this a custom event down here in case there's other things that we want to make him die from. And we'll call this custom event death. We'll call it off of the end here, death. And let's make him ragdoll. So we're going to grab the mesh here, and we're going to set collision enabled, and we're going to set the collision as physics only, collision enabled query and physics. Plug that in. You can also drag off of mesh, and we can set simulate physics and check simulate, and set physics blend weight, and we're going to set the physics blend weight as 1. Just to make sure this is working, we might also just put a print string in here. So print string, and the string it's going to print is whatever it's setting the health to. Let's give that a whirl. So you can see up the top right, health is 130, 110, 90, 70, 50, 30, and then one more hit, and he's ragdolling. Now, the ragdoll is not great. It's because of the physics asset on this character. So we can have a little bit of a play with that, but I'm not going to go in depth into changing the physics asset. In mesh here, we can find the physics asset. So yeah, once again, I'm not going to go super in depth about this, but we will set up some headshot damage after this. So we do want to clean this up a little bit. Especially if we want to do headshot damage, we want to make sure that this one here is really done well. So we're just going to move these around and rescale them a little bit so that they're not crazy big hitboxes. But you also want to make sure that you don't, move this way out of where it should be. So from different angles, look at it from different angles and make sure that, that includes his hat. And I'm just going to play with these a little bit, rotate them and move them around. They seem to have really strange rotations by default. Really strange rotations. His body. I'm actually not going to mess around with this too much. If the ragdoll isn't great, it's not really a big deal. It stops becoming a bug and starts becoming a feature. Could just be a really goofy feature in our game. So yeah, you can mess around with this as much as you like. There's these things that stop the joints from rotating too far. There's all sorts of things you can set up in here, but that'll do for now. Let's see if that made any difference. No, it's still a pretty goofy ragdoll. Anyway, let's set up some headshot damage on our zombie. Actually, just before we do that, guys, there's one other thing we need to add to this zombie's death logic, and that is to remove the collision on the capsule component. So just grab the capsule component from up here and find set collision enabled and leave this as no collision. The reason for that is when our zombie dies, this capsule component just stays where it was and then you can't walk through it. So now with set collision enabled to no collision, that means when he dies I can run through here and I'm not running into his capsule component. Nice. Okay, let's implement some headshot damage. And how we're going to do that, guys, is with something called physical materials. So what we can do is up here at the top right, click project settings, and we can search for surface. Whoops. Surface. And here in physical surface, we can create a couple of custom surface types. So I'm going to call one headshot and the other one body shot. And that's all we need to do in here. We can close this and then we can just do it here in the mesh folder. We're going to right click and we're going to look for a physical material here under physics, physical material, and hit select, and we're going to call this PM for physical material headshot. And we can duplicate that one and call the other one body shot. Can open up PM headshot and then change the surface type here to headshot. Save and close that. And then open body shot and change the surface type to body shot. Save and close that. And then in the physics asset here, this is where we're going to set this up. So these components will have these sort of capsules will have different physical materials, and then on our line trace we can do different amounts of damage for different physical materials. So I'm going to tighten this one right up so that it's a bit harder to get a headshot, like so, and I'll bring it up a bit so it involves his hat. That's pretty good like that. That'll do like that. What we're going to do is with that one selected, down here we can find physical material override, and I'm going to set that to our PM headshot. And then I'm going to select, click over here and press Control A to select it all, and then Control click the head to unselect the head, and then change the physical material override on everything else to our body shot, PM body shot. You can save this and close this. We're not going to do anything else in here. And then our BP third person character, we are now going to this is going to get quite messy now. We are going to sort of make a little bit more room here, like so, and we're going to do a branch on physical material here. So off of physical material we can do a switch, so it should be surface type, get surface type, there we go, get surface type, and then off of get surface type we can do a switch on E physical surface. Plug this in here, and we're going to do the same down here off of physical material. Can get surface type and then switch on E physical surface type. So depending on what's hit, this these kinds of nodes, these switches, are like train tracks. So if the physical material that we hit is of type headshot, it will execute that code there, and if it's a body shot, it will execute that code there, and if it's anything else such as the walls and the ground and stuff in our level, it will do this one here. So we're going to have to duplicate these a couple of times. I'm going to duplicate this one here, and off of headshot I'm going to execute apply damage, and I am going to say multiply the damage by 2. Let's go crazy. Let's multiply it by 3. So headshot damage will multiply the base damage by 3, and then if it's a body shot, it will just do the regular amount of damage. And we can do that down here as well for the hip firing. We're going to duplicate this, and if it's a headshot, we're going to multiply the damage by 3, plug it into the base damage, and if it's a body shot, just do the base damage. So it's starting to get a little bit messy here, lots of branches, but yeah, this should work now. Let's bring back the print string for the damage. So BP zombie on receive damage. The print string is still there, very good. So let's have a look and see if this is working. If it's a headshot, it's not actually printing the string. That's odd. Maybe out hit, hitting something, switch on surface type. I forgot to plug in the hit actor, so damaged actor. My bad. Make sure you plug hit actor into damaged actor so it knows where to pass this apply damage to. That should be working now. Yep, my bad. Let's have a look with a headshot. Do my best here. If I can actually hit him. 110, 50. Yep, so that's done 60 damage. And just a couple of headshots to get a kill. Nice. That damage is working, but it is a little bit tricky to aim. So let's add a crosshair to our HUD. Alrighty guys, I've literally just gone to Google and typed in crosshair in the image searches, and I've found this one, which you can tell by the checkered background here. It doesn't have a background. The image is literally just the crosshair. I've downloaded it, and then I've just hit import and imported it into my HUD folder. And the next thing I'm going to do is open up my UI main. I'm going to find image here and just drag it into the canvas panel. And then up here in anchors, I'm going to select the center of the screen here. And then you can change the position X and the position Y to 0 and 0. It will also do something with the scale here. It's going to scale it not uniform. So I'm actually just going to make the scale 300 and 300. And then I'm going to bring it to the left by 150 by putting position X negative 150, position Y negative 150. And then you can see that's in the center now. And I'm just going to click on my image so it's selected there, my texture, and then over here under appearance and brush you can find the image, and this will set it as whatever you've got selected in the content browser. So I've got my crosshair there. I can compile and save that, and if I hit play I have a crosshair. But what you'll notice now is that our hits won't actually hit exactly where the crosshair is, and the reason for that is our line trace logic. So what I'm going to do is I'm going to make a little change to our line trace logic, which will make our spread, our random spread, not quite as consistent, but it will make where the bullets land much more consistent. So what I'm going to do is, before our branch here, our aiming branch, I am going to do another line trace by channel. So I'm going to grab this one and duplicate it down here, plug this one in, and from up here I'm going to grab all of this stuff to do with the follow camera location and rotation, duplicate it down here. The world location will be my start point, and the end point will be my world location added to my forward vector. Plug that into the end point. I'm going to change the trace channel to visibility, and I'm going to leave draw debug type on for duration for a moment, just to show you what this one's doing. So this one is drawing a line trace straight from the center of the camera. It's a little bit hard to see there, but if I move the camera, you can see it's drawing from right where the center of the camera is to where the center of the camera is pointing, which is right where my crosshair is, right in the center of the screen. So what we're going to do is take that hit result and use it to find the end point of our traces here. So off of out hit, we can break hit result, expand this one here, and then instead of using this camera stuff here, what I'm going to do is just disconnect this one for a second to show you that it's working and to double check that it is working. I'm going to disconnect this one here, delete all this camera stuff, plug location into endpoint here. So this hit location is now the endpoint of this trace. That should be working. And it is. Very good. And we just want to add our random spread back into the equation here. So I'm going to grab this location and plug it onto this addition node. I will remove this pin, plug this into the endpoint. Same down here. Remove this extra pin, plug this into the endpoint. But these random float in ranges will probably be needed to need to change now, because that's way too much spread for aiming down the sights, and that's way too much spread as well. So as I said, our bullet spread is going to be a bit less consistent now, because it's going to be actually maybe too consistent, because it's going to be probably the same at any range, because this is now spreading from this impact point. And there's also one other thing we're going to need to do to make sure that these hits actually land. Just going to make these, what did I make this one? Minus 50 to 50, minus 100 to 100, and I'm just duplicating this to save time so I don't have to type it in again. Let's have a look at that spread now. Yeah, that's okay. It's a little bit unforgiving, this amount of spread, but that's fine. The other problem here is that you see some of these lines are not hitting. I'm just going to get rid of that this line trace that's drawn off the camera. We can change draw debug type to none so that we don't see that anymore. But you'll see that some of these lines are actually not reaching their destination. So what we might do is just add a little bit more to that line trace so it goes a little bit beyond that hit point. And actually, while we're at it, there's another issue we can address. So if I just hit play here, you'll see that the amount of spread, whether I'm 1 meter away, See, that's quite extreme. Or 20 meters away is the same amount, and the reason that is because we're just adding this random spread at the hit point here. So we've got the hit location of this one, and we're just adding this randomness to it. So we're going to change this a little bit so it's a bit more consistent. What we're going to do is I'm just going to add a reroute node to this hit location here, and I'm going to do the hit location minus the socket location on the weapon, and what this gives us is the vector between the end of the gun barrel and the hit location at the center of the screen. So what we then want to do is convert this into basically a forward vector of that vector. So how we're going to do that is divide it, so divide by the vector length of this. Sorry, this is a little bit messy here. I'll just do this up here. So hit location minus the socket location, and then we're going to divide that by, also drag off of here, and get the vector length. So what this does is basically give us a vector but only 1 centimeter long. So then we can multiply this by whatever we like, and we've got a vector in the exact direction from the end of the gun barrel to the hit point in the center of the screen, but it goes through that point and then it goes as long as we multiply this for. So I'm going to multiply and then right click on here and change this to float single precision, and I'm going to make this 15,000 for 150 meters. Okay, if I add a pin here and add that, you'll see a stark difference now, because this random spread is actually calculated, it's added on to this vector at the end. So 150 meters further away than what was happening just now. So if I test this now, you'll see that here the spread is very low, right? And over here it'll be a little bit higher. And if I pause that and I press F8 to eject, you'll see we're actually drawing line traces 150 meters long, but they're still going through exactly that point where the camera is pointing at and hitting here. So now the spread will be much more consistent. We need to do the same as well with the hip fire. So instead of copy pasting, we'll just do it again just to solidify this in our minds. What we'll do is I'll create a reroute node on this location, and I'm going to do the location minus the socket location. I'm going to then divide this by the vector length of this one. Vector length. And I'm going to multiply that by single precision float 15,000. I'm going to add a pin here and plug this in. I'm not going to bother tidying this up now that it's set up. We're not actually going to touch this stuff anymore. That is a pretty good setup, but we do need to play with our randomness here. So I'm actually going to make these negative 150 to positive 150, and I'm just going to duplicate this so I don't have to type it again. Plug these in here, negative 150 to 150, and we'll make the other one negative 750 to 750. It seems like a lot, but for hip fire, I've tested these values and they work pretty good as a hip fire spread, so that if you're close up to the enemy, you'll hit it quite a lot, but if you're 25 meters or further away, you'll miss quite a lot of those shots. So let's just test that really quick to make sure it's working. It's working. Nice. Little bit of spread here, hip firing, you see that much spread. a little bit further away, a little bit more, and then this far away, quite a lot more. Nice. And if I pause that and hit F8 to eject, so this is the hip fire, you'll see that's our spread at 150 meters. Pretty nice. One other thing we need to do here is make a different channel for this one so that it hits what we want it to hit, because this is basically going to be our targeting line trace right here, our targeting. So let's up here click on settings, go to project settings, and I believe it was trace channel. We're going to add a new trace channel and call it targeting. Close that, compile this, and change the trace channel to targeting. And then what we're going to do in our BP zombie is make sure that with the capsule component selected in the collision presets, we make sure targeting is on ignore. So everything should be ignore except for camera. That's fine. And also if we stay searching for collision and then select the mesh, we want to make sure that targeting is also on block on the mesh, which it should be by default. The only one it's ignoring is the visibility line trace. Nice. So if we change this one, let's change the trace color to blue here so we can tell the difference, and the draw debug time on forward duration. This blue one should be hitting our zombie there, and it is. Now this is a pretty nice system, guys, because we got a crosshair in the center of the screen, and basically that's very accurate because that's where our line traces are going. I know the gun isn't pointing exactly there in the center of the screen, but for our purposes this is a pretty nice setup. For a first game, I think this is pretty clean. The only thing is, you'll notice that if the center of the screen is pointing at a spot on the wall there, and you're actually facing around the corner, if I hit pause there, F8 to eject, and look down, you'll see that the line trace is going on a bit of a funky angle there. You could probably get it going even more if you got really close, just pretty much as close as you can get without the barrel touching. You'll see that there's a pretty funky angle going on there. The traces are coming sideways out of the barrel of the weapon, but that's alright. For the purposes of what we're doing here, this is a pretty nice system as it is. We've got some nice zooming here, reloading, and some locomotion, and a really nice line trace. So let's start looking at creating some hordes of these enemies, maybe in waves, huh? Actually, before we do that, there's a couple of things we might want to do in here that could be kind of cool. Like we could take a random float in range and duplicate it up here on our spawn, the bullet casing logic. I'm going to duplicate it here, plug it into this multiplier on the get right vector. So this is what is creating the kind of magnitude that our bullet casings eject at. And let's change this from 90 to 150. So now our bullet casings are going to come out at random. So nice. It's a little bit less uniform. Looks quite nice. What else can we do that might be kind of cool? I did mention earlier that we were going to change the sprinting setup. I'm going to do that now because I don't think, well, obviously walking is too slow. It's annoying that walking is our default speed. So what I'm going to do is change the default speed in camera movement to 500, max walk speed 500, and we're going to put this on a flip-flop. So I'm going to disconnect this logic here. A flip-flop is basically a toggle. So off of pressed left shift, sorry, we'll find a flip-flop. As I said, this is like a toggle. And I'm going to make a new variable and I call it was sprinting. I know this seems like odd wording, was sprinting, but you'll see exactly why I've called it that in a moment once we've set this up. We're going to set this off of this A and B on flip-flop, and I'm going to leave it as false at the top and true at the bottom, because by default we changed our walk speed to the jog. Okay, and the first time we press left shift, it's going to fire this A logic and change was sprinting to false, and then the next time you press it, it's going to execute B and A and B and A and B each time you press left shift. Okay, and then what I'm going to do is create a custom event, and I'm going to call it set sprint / walk. I'm going to execute that off of the end of here. Whoops. Sorry, I am a rubbish typer. Set sprint / walk, and I'm going to plug both of these in here. And then off of my set sprint / walk custom event, I'm going to get was sprinting and make a branch. And then off of true, I'm going to set our sprint speed as long as we're not aiming. And off of false, I'm going to set our walk speed. That should be good right there. So in case this is a bit hard to follow, basically what I'm doing is making sure that when I aim, I'm not changing my walk speed indefinitely, so that when I aim, it will go back to whatever speed we were moving at before. And we also just need to, on our aiming logic, which will be all this camera logic way out here, just going to move this back in so it's not lost and forgotten in oblivion, and I'm just going to call this custom event right here off of released aiming. So it will remember what we had it set to, and it will set it back to that. So here when we click the right mouse button, we're setting our walk speed to 150 for aiming, and then upon release it's going to execute this custom event which has this boolean set. So every time you press left shift, it sets this boolean to know if we should be sprinting, and sets it again every time you release the right mouse button. So this should be a lot cleaner because we're sprinting, and then if we aim, it will it should go back to sprinting. I know what it is. It is the default value of was sprinting. So we need to select was sprinting and make sure the default value is true. So when we start play and we haven't pressed shift at all, it's already set to sprinting because that's our default move speed. Sorry about that. So now was sprinting, if we aim, it'll go back to sprinting like so. If we press the left shift button and we're walking, our walk speed is now set to walk, so on and so forth. So you could be walking, you aim, and then you press left shift and release aim, you'll start running. Nice. Alright. Let's keep going, guys. Alrighty, I've just had a pretty cool idea of something we can add. I want to add the ability for my character to sort of run around when they're not aiming or firing, and then they will just face away from the camera, like over the shoulder, when we're either aiming or firing. So we want to implement this when we press the right mouse button or the left mouse button. So this is where we're going to implement our event. But while we're here, it's probably a good time to mention that to help organize your event graph, you can see that these standard ones here that were in the event graph by default have these little boxes around them with a little description here. What you can do is you can highlight sections and press C, and it will create this comment box. And then I can put here aiming logic. And you can also customize this over here, so you could make it blue if you wanted. And then I might just, that's our reloading, and I might just put all this in one, highlight all of that, press C, and that can be our firing and reloading logic. I might also make that blue. Alrighty, so we're going to create a custom event, and I'm going to call it set aiming orientation and yaw. This name will make more sense to you in a moment. Set aiming orientation and yaw. The reason I'm calling it this is because we are going to set a function called orient rotation to movement, which is the default. You may remember we unchecked that in the beginning, and use controller rotation yaw. So these settings we played with both of these in the beginning to give it the sort of feel that it has at the moment, but we're going to set it up so that it switches these on and off depending on what we're doing. So I'm going to call this event on the right mouse button. I'm going to call it right at the start here. So I'm just going to move these back here, and right in here I'm going to call set aiming orientation and yaw, and I'm also going to call it here, and I'm also going to call it here on release of the left mouse button, and I'm also going to call it when I press the left mouse button, but I want this to be part of my firing loop in here, my automatic firing loop in here. What I might actually do to clean this up and make some more space is put my bullet casing ejection in a custom event. So I'll just create a custom event down here. If you couldn't tell already, I love custom events. I find them very handy. I'm going to call this one eject casing. I'm just going to disconnect this here and this here, and I'm going to grab all of this stuff, move it down here, plug it into eject casing, and then I can just call eject casing in here. Nice. Alrighty, I'm just going to grab all of this stuff after the branch here and just move it over a little bit, and I'm going to call my set aiming orientation and yaw right here. So that should be everywhere that we need to call it. Let's do some logic down here. So the very first thing I'm going to need is a branch, because I want to check, am I aiming or firing? So can fire, a little bit of a misleading name the more I think about it, but can fire is what we need because it's what's set here, and it's only unset once we release. So if can fire is true, then we are firing. Can fire, and we'll get aiming question mark, and we want an or boolean. So if we're doing either of these things, this branch will ring true. Okay, and if it rings true, we want to set another variable which we can create now, and I'm just going to call it already setting question mark, and I'm going to set that here, and I'm going to use this as a condition on this branch as well, so that if we are already setting our aiming orientation and yaw, we don't want to keep on setting it, and we will uncheck this sort of at the end. So off of this or boolean, I'm going to also grab an and boolean, plug this in here, and already setting, and a not boolean. So if we're firing or aiming and we're not already setting, then we can fire off this logic over here. Okay, we're going to use another timeline here, so I can add a timeline, and I'm just going to call this set rotation timeline, because this is the timeline on which we're going to set our character's rotation to face away from the camera and get ready to fire. We can double click on set rotation timeline to open it up, add a new float track. I'm going to make the length of this float track 0.5 seconds, and I'm going to shift click on here to add twice to add 2 points. I'm going to click on the first point, set the time to 0 and the value to 0, and the second point I'm going to make 0.5 and 0.5, and highlight both of these, right click, click auto to smooth it out. That's all we need to do in here. We can close that, and now what we're going to do on update of this timeline is set the actor rotation. Set actor rotation. The target will be the self. So we're setting the rotation of our character. What we're going to use here is something called an f_interp_to. Now, the best way to describe this is basically it takes a current figure and a target figure, and based on amount of time that's passed and a speed, it will push this figure towards this target figure and then return a value. So what I'm going to do is I'm going to right click on this new rotation here and split the struct pin, and I'm going to plug this return value into the Z axis, the rotation on the Z axis. That's our character's rotation, relative to the floor. The delta time is going to be the track that we made on this timeline. That's the time, so 0.5, it goes up to 0.5, and the interp speed can just be about 10. Okay. Now our current rotation, we want to use our capsule component. So we'll grab our capsule component here, and we will get world rotation. Get world rotation, and then I am going to break this rotator into the 3 axes, and I'm going to plug the Z axis into the current. Okay, so that's our current rotation, and our target rotation is where our camera is going to be facing. So I am going to get the player camera manager, and I am going to get world rotation, and then I'm going to break this rotator and plug in the Z axis into my target on my f_interp_to. What we also want to do when this is finished is unset orient rotation to movement, and reset use controller rotation yaw. But we also want to set those up, change the defaults of what we set those up to. So we can select the root up here, and we can search for orient rotation to movement, and we're going to have this as true. Okay, and we're going to search for use controller rotation yaw, and we're going to uncheck this. So now our character will run around like it does in the default third-person template. Unless we fire or aim, what we're going to do is grab the character movement here and set orient rotation to movement as false on finished, and also set use controller rotation yaw as true. Okay, so that is that setup for when we fire or aim. It's going to run this timeline, and based on that timeline, it's going to set our actor's rotation from what it is to the rotation of our camera. And then once that timeline's finished, it's going to lock our character to that position facing away from the camera. And then what we want to do on a timer is unset all of this. So if we don't fire or aim for, let's say, 1 second, we want to undo all of this. So what we're going to use is something called a set timer on event. Might be set timer by event. Set timer by event. Okay. This is going to plug into the false here. So whenever this function is called, if we aren't firing or aiming, and we have already set this, then we want to unset it. And what we can do here is we can set a timer here, and we can plug an event into this node here. So once again, create a custom event. Love these things. And we're going to call this one set running orientation and yaw. So back to running around. And if we plug this little red box here into this little red box here, basically what this is doing is every time this fires, boom, this fires off, it resets this timer to 1 second. So every single time, boom, 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 it will reset it back up to 1 second, and only when this 1 second gets to 0 will this event actually fire. So if we haven't been firing or aiming for 1 second, then it will set it back to what it was. So all we need to do is grab these ones here and duplicate them down here. And we're going to make these the opposite. So we're going to check this as true and check this one as false. And we also need to just change already setting back to false. Like so. Now this is all set up and ready to go, but I'll tell you now that this is going to cause a problem with our line trace from our camera, because it does something really funky. It's to do with the camera boom, the spring arm, I believe. But basically what we want to do is change our line trace from the camera, our blue one, to use this camera manager instead. So I'm going to find my line trace logic down here, and instead of follow camera, I'm going to get my player camera manager, and then I can just plug this in to these ones here. Actually, I don't need 2 of these root component nodes, I only need 1. So I can plug that root component node into both of these. That should be all good to go. So if we've just fired, now I haven't fired for a second, so I've got orient rotation to movement on here. So you can see my rotation is orientated to whichever direction I'm moving. And if I shoot, it turns that off, and then after 1 second it turns it back on. So I could be running around, let's say I'm running away from zombies, and then I aim, spins around and locks that aim to the zombie. Nice. I think this is our locomotion and our, our firing logic, our reloading, our ammo, our line trace and all that. I think this is good the way it is. So let's go ahead and put all this stuff into our very first game. What we'll do next, guys, is we'll start making some changes to our map here. So we're going to start building our tunnel. What I'm going to do is just grab this wall and make it a bit shorter. And then I've got a little tip here I can give you, is if you hold Alt and click on the widget to move it or rotate it, you will actually create a duplicate. Another thing you can do is you can hold shift and move, and the camera will move along with it. So let's say I'm just going to delete this one. Let's say I wanted to copy this one and put the copy over there. I can hold shift and alt, click on this arrow and drag it, and my camera will move with it, and I've made a duplicate. Now this doesn't need to be exact, but just as long as our character can't, you know, run off of the screen, off of the map and fall off of the map here. So I am also going to duplicate the floor here. I'm going to make sure it lines up first, and I'm going to scale it down here and make it fit in here. Like so. And I'm also going to make it quite a bit longer, make it about that long. And I'm going to grab these walls here, and I'm also going to duplicate those, holding shift and alt, and then dragging that over to there. Make sure this lines up like so. Scale it up so that it reaches the end. Like I said, doesn't have to be exact. I'm also going to hold alt and duplicate this one and move it to the other side. There we go. And I might just grab, what's the best piece to use as the end piece here? I'll just grab one of these, hold shift and alt, hover between those two arrows to move it on both axes. Line this up. You probably want to make sure that your grid snapping is switched on if you're doing any of this stuff. Just makes it a little bit easier to resize it to what you need. My scaling snapping is not switched on, which is why that one is a little bit trickier. But once again, doesn't have to be perfect. Then I'm going to grab this floor and I'm going to duplicate it and move it up and make a roof. Like so. Okay. The next thing I'm going to do is just make sure that all of these are the default material, because later on when we spawn our particle effects, we want these ones to spawn a certain particle effect, and then our gate is going to spawn a different one, and our zombies are another one again. So I'm just going to get rid of this blue box, and then over here I'm going to select all of the cubes, SM cube. I'm literally just going to select all of this stuff. That starts with static mesh to get all of this stuff in the world, and then I am going to, in the details panel, find my physical material override, and I'm going to change this to my default physical material. Okay. Okay, let's work on the spawning logic for these zombies. So what I'm going to do is I'm going to grab my spawned zombie here, and I'm going to move him just inside the tunnel here, about in the middle there, maybe a little bit further back than that. And we're going to use his location there as the spawning location for our hordes. We can move that location back later on, But just for now, right here is fine. And I'm going to add a couple of lights in here just for dramatic effect. So if I click here, quickly add to project and lights, and I'm just going to choose a spotlight, and I'm going to move it up into the corner here and rotate it so it's pointing down the tunnel and out a little bit. Okay, and what I can do is in the details panel here, I can change the intensity. I'm going to make it 100, and the attenuation radius I might make 2500, like that. Okay, and then I'm going to duplicate this one by holding Alt and Shift and move this one over the other side here, rotate it out a little bit. There we go. We've got a couple of lights there so that we can see our hordes spawning more easily. You can duplicate these and put them down the tunnel. You can put whatever you like. You can you don't have to work with these basic, this basic material. You can head to the Quixel Bridge and grab some 3D assets. You could make a whole new level if you like, but just for the purposes of this tutorial, this will be absolutely fine. Okay, so let's do some spawning logic for our hordes. Where we're going to do that is in a custom game mode. So I told you how to find the game mode earlier in world settings. We've got this game mode override, BP third person game mode. It's the standard one, but we're just going to make our own. So in _main, right click, create a new folder, call it game mode. And within game mode, we're going to right click, create a new blueprint class of type game mode base. And I'm going to call this BP _ game mode. Keep it simple. Okay. Now that BP _ game mode is created, what we can do over here in the game mode override in world settings is click this little arrow to use selected asset from content browser. So we've set it as BP game mode. But we also want to change this in our project settings. So go into project settings, and under maps and modes, you can find default game mode, and you can also click the arrow here to change it to BP game mode. Close that, and we can open up BP game mode, and probably the very first thing we want to do is in class defaults. So if you click up here, class defaults, over here you'll find the default pawn class, and you want to make sure that this is your character. So for me it's BP third person character. Make sure that is selected. Okay, and if we head on over to the event graph, this is where we're going to keep the logic for our game mode. And a game mode typically just is a place to store all of the rules and regulations for the game mode. You wouldn't store, for example, your character's inventory in here. You would just have the logic that dictates what kind of game mode you're playing. Okay, so we're going to start by deleting event tick. We don't need tick in our game mode. And we're going to create a couple of custom events and variables. So I'm going to create a custom event and just call it start game, maybe. Whoops. Start game. Start game. That could be cool as well. And let's also create one called spawn wave or spawn enemies. On event begin play, I'm just going to call start game. And on start game, I am going to, let's put a delay in here of 5 seconds. And after 5 seconds, I'm going to spawn enemies. Okay, so 5 seconds after event begin play, enemies will start spawning. And to spawn the enemies, we're going to need a couple of variables. Let's just call the first one total enemies of type integer. and let's duplicate that one and call the other one remaining enemies. We'll also need one called current wave. And that should be all good for now. If we compile and save, we can then change the default value of current wave to 1 because we want it to start at 1. Okay. And what we're going to do is we're going to get our current wave and we're going to multiply it by how many enemies we want in our wave. I'm going to make this 3. And then I'm going to set our total enemies off of that. So the total enemies in the wave is the current wave multiplied by 3. Okay? And we also want to set remaining enemies as that, whatever that is. Now we're going to use what's called a for loop with break. For loop with break. So this is going to loop and then eventually break. And the last index of our loop, we want to be the total number of enemies here. Okay? And off of the index, what we can do is check if our total enemies is not equal to the index. So if our index hasn't reached our total number of enemies yet, then we want a branch. And off of loop body here, if our index has not reached our total number of enemies yet, then we want to spawn more enemies. So spawn actor from class, and right here we can choose our BP zombie. And on collision handling override, we want to select try to adjust location, but always spawn. So if there's a problem with collisions in the spawning location, it will just move the location a little bit, but always try to spawn. We can drag off of the spawn transform and promote this to a variable, and let's just call it spawn location. If we compile this, we can now set a default value for the spawn location, and that's going to be, we're going to use this guy to find whatever this location is right here. So over here in the details panel, we can see his location and his rotation. So I'm going to right click here just on location and copy this. And then in the defaults for the spawn location here, I can paste in that location. And we can see the rotation here is just 180 degrees on this z-axis. So I'm just going to set this third argument on rotation to 180. These are called arguments, by the way. Now, what we want to do if our total enemies is equal to the index, so this is going to loop a certain number of times, and the number of times it's going to loop is the total enemies of that wave. And once the total enemies that have been spawned, once the index is equal to that, we want to break this loop. So we're going to go from false here around to break, and I'm just going to double click and add a couple of reroute nodes like so. And that's that pretty much. That's going to spawn them, but we also want to increment this wave when they're all dead. So we're going to need to know when they're all dead, and how we're going to do that is with another custom event called enemies killed. And what we're going to do on enemies killed is just take our remaining enemies, and we're going to do what's called a decrement int. Decrement int. So this just decrements the integer by 1. So it minuses 1 every time this is called. It minuses 1 off of the remaining enemies, and then what we can do is check if that's equal. If that's equal to 0, put a branch here. If it's equal to 0, we're going to go to the next wave. So let's create another custom event and call it wave increment. And here we're going to call our wave increment custom event. Our wave increment custom event is going to be, well, first we're going to just increment the current wave. So let's get our current wave and we can just increment it. So this is going to add 1 to our current wave, add 1. And then maybe we can have a delay by 5 seconds. So we've got 5 seconds between waves, and that will give us time to show something on the screen and maybe play an alarm sound or something like that. And then we're going to spawn more zombies, spawn enemies. Nice. So here's the basic bare bones of our game mode logic here. We're going to be adding to this, but this is our spawning logic here. One thing that we need to do on our death event in our zombie is cast to this and call that an enemy killed. This is actually misleading here. It's not enemies killed, it's just one enemy has been killed, enemy killed. So we need to call this when our zombie dies. So we can find our zombie blueprint, BP zombie, and then on our death here, what we can do is cast to my BP game mode, and on the object we can just get game mode. As BP game mode, we can call the enemy killed event. Nice. We should be able to give this a go now. I'm actually just going to move him a little bit out of the way so he spawns further back there. And if I hit play now, after 5 seconds, we should have 3 zombies spawn right there in the location. And if I take out 3 zombies, I know there's 4 here, but if I take out 3, 5 more seconds should go by, and there we go. We've got our next wave spawning. So that's working well. But let's just create a widget right now, so that we know our next wave is coming. It's not too hard, and we've got our current wave int in our game mode here, so we can use that. So let's go into our main and HUD, and let's create another user interface widget blueprint. User widget, select, and let's call this UI underscore wave warning. Something like that. Open this up. I can find a canvas panel over here and drag it in. And I'm also going to find text here and drag it in and make this a bit bigger. And up here in anchors, anchor it to the center. Let's make the text size 80. And I'm going to make it yellow. And I'm also going to change the outline size to 2. I'm going to change this text to wave starting. And I'm going to make a few spaces in the middle here for our wave number. Okay? And I'm going to make this box around the same size, and then we can see here if we want to get this totally in the center, I might just make the size 980 and the size Y 120, and then what we can do is minus half of that off the position to get it exactly in the center. So minus 490 and minus 60, and we've got it right in the center there. I am then going to duplicate that, and I'm just going to change it to XX to denote 2 digits, and I am going to size this so that the borders are touching the end of the E and the start of the S kind of thing. So I'm putting it kind of in the center here between these two words, and then I'm going to change the justification of the text down here to center, like so. And then I'm going to click bind on the text and create my binding. Cast to BP game mode. Object reference will be get game mode. As BP game mode, get current wave, and then convert that integer to text. Nice. We need to create this widget. So in BP game mode, what we might do at the very start is right here before the delay, we can create the widget. Actually, we'll create the widget on event begin play. So create widget. Just turn caps lock off there, and find your UI wave warning. Okay, and then what I want to do is promote this return value to a variable, and we'll just call it wave warning widget. Nice bit of alliteration there. Set this and add to viewport. So we're adding that to the screen, and then we're starting the game. So this is going to add this widget to the screen that will say wave 1 starting, wave 2 starting, wave 3 starting, but obviously we don't want it to show all of the time. And now one of the common mistakes that beginners make is they will destroy this widget and then they'll create it over and over and over again. And that is way too resource intensive. So what we're going to do is we're going to hide its visibility. Okay, so what we can do after this delay is grab our wave warning widget here and set visibility. And we're going to set the visibility as hidden. Okay, and then spawn the enemies. I'm going to grab these two and I'm going to duplicate them. So when we increment the wave here, I'm going to duplicate this down here. We've increased the wave number. We can make this visible. And then after 5 seconds, when we're about to spawn the enemies, we can make this hidden, like so. That should be all good to go. If we hit play, we got wave 1 starting, very nice. It should disappear and the enemies should spawn. Take 3 of these guys out. Nope. Wave 2 starting, nice. And then they spawn, very nice. Alrighty, let's start implementing the logic for these zombies, because obviously we want them to move towards us, we want them to do all kinds of things like attack us. So let's start working on that. Now there's quite a lot that goes into this, so you're gonna have to bear with me, but the very first thing I want my zombies to do when they are created is start moving to my gate. So I'm just going to get rid of these and get rid of the tick. Don't need tick. On event begin play, I'm going to call a custom event called move to gate. So on event begin play, move to gate. And for our zombies to move, we need to, because they're being spawned, we need to do something with the settings. We need to go to class defaults here and search for AI. And then down here in pawn, you'll find auto possess AI placed in world. We want to change this to placed in world or spawned. And then AI controller class can be on AI controller. This makes sure that when our game mode BP spawns our zombies, they actually have the AI possesses those pawns. So what we're going to do on move to gate is a node called AI move to. So we can drag off move to gate and find AI move to. The pawn is going to be a reference to self. That's what we want to move, is itself. And the destination, we can promote this to a variable, and we'll call this gate destination. Okay, and we're going to do the same thing as we did with our spawning. We are going to, I'm going to just drop this right under the edge here, and I'm going to right click on the location and copy that, and then I'm going to paste that. You might have to compile this so that you can set the default value, and I'm going to right click here and paste in the destination of the gate. We also just need to add what's called a nav bounds mesh. So this is what generates the navigation for these AI pawns. So up here we can add, and in volumes you can find nav bounds mesh, nav mesh bounds volume. Drag this out, and we're going to need to scale this up to basically encompass our entire map wherever we want them to move. So I'm going to start by positioning it here in the center, scaling it out to there, and then I can have a look from this angle, scale this out to there so it encompasses basically our whole map on the ground floor. We don't need anything up on the very top. So with this selected, we can press P, and it will give you a preview of the generated nav mesh bounds. We don't really need to change anything here because we've got a really basic map, but we will need to change something about our gate to make sure that they can walk through our gate once it's come down. But with that done, what we can do is press P again to get rid of that preview, and now if we hit play, can see a gap in my wall there. I'm going to have to fix that. These guys are moving to that location. Very nice. Just going to fix this huge gap we've got here. There we go. Nice. Straight away, the first thing I noticed is my zombies are moving very, very fast. So I'm going to change the default move speed to 250. And then I'm going to make this 450 when they're aggroed and they're running towards the player. Let's start setting up our gate blueprint because they're going to need to interact with that. So if we click up here and go to Quixel Bridge, I'm going to look for a gate in 3D assets. I can search gate. And I'm going to use this one here. It's the one that I've already got downloaded. So if you haven't already, select your quality and hit download. I downloaded mine in nanite quality just because. That's really up to you. Doesn't matter too much. Oh, I'm downloading it in a different quality here. I can actually just select the quality I've already downloaded and hit add, and that will be added to the project now. So I can close this, and you'll find a folder here called Megascans 3D Assets, and there is my fence right there. Straight away, what we can do is open this up and have a look at the collision. So I'm going to add a box simplified collision. So you'll see this little box has come up around it now, so it has collision. Very good. And I believe in here as well we can search for nav and has navigation data. We can uncheck that because we don't actually want we don't want it to affect our navigation. It causes some problems. So we can close that now, and what we're going to do is create a blueprint for this gate. So in main, I can create a new folder. I can call it gate, and in here I'm going to right click, create a new blueprint class of type actor, and I'm going to call it BP_gate. Open this up, and in the components panel here, add a new static mesh. I'm going to call it gate mesh, and I'm going to drag it onto default scene root so it replaces the root. So gate mesh becomes the root, and right here we can search for our gate static mesh. What was it called? Modular iron fence. So I can actually click on this static mesh to select it, and then in my BP gate I can click this little arrow to set it as the static mesh, like so. Now this isn't going to be nearly big enough. If I find my gate BP and drag it out, you can see right away it's really quite small. I'm going to make this quite a lot bigger and maybe have two of them next to each other. So what I can do is, with this little padlock closed, I can change the scale to 10. Now it is 10 times bigger. And let's have a look at how that looks. Wow, that's actually way too big now. Let's make this 5. That's getting a bit warmer. So yeah, I think if I have two of those, that should fit quite nicely. So I'm just going to duplicate this gate mesh, leave the other one as called gate mesh 1. I'm going to move it over and line it up like so. Doesn't quite fit, but I like the size of this gate, so I am actually going to resize this opening to suit. So I'm going to move that over, resize these. Whoops. Nice. That'll do, just like that. As long as the zombies can't get around it, that is absolutely fine. Yep, position's all good. That's fine the way it is. I can actually open this up now, and I'm going to add another component on the root. I'm going to add a collision box collision. So this is just basically a way of checking if anything is overlapping with this blueprint actor. So I can scale this up. I'm going to make it as wide as the fence here. And about the same height. That's pretty good. A little bit taller. And I'm going to make sure that it sticks out on both sides, because our player and our zombies are going to need to interact with that. Nice. That should be fine, just like that. Actually, while we're on the gate, let's set the physical materials so that later on when we spawn our particle effects, we can spawn the correct particle effect for this kind of material. So in BP gate, in the gate folder, what I might do is just right click in here and under physics, create a new physical material of type physical material. And I'm going to call that physmat underscore gate. And if you remember, in our project settings, we can search for surfaces, and we've created our headshot and our body shot surface types here. I'm going to create another one called gate, close this, and then open up physmat gate and surface type, change that to gate. And then in our static mesh here, we can browse to the static mesh and open this up. Or it might actually be, just be part of the blueprint. So in the blueprint, select both gate meshes and physical material override here. We can search for our physmat gate, select that. Nice. We may as well go ahead and spawn some particle effects, because that could be, yeah, let's do that now. We've got all our physical materials, so let's do that now. You can find your third person character's blueprint, and actually while we're here, we want to make sure that trace complex is checked on our line traces here. This is to make sure that they can go through our gate. So make sure trace complex is true, and let's also on our gates box, we can check the collision on the box, and on collision presets change this to custom, and we want to ignore our targeting and our projectile here. We don't want our bullets to target or hit this box. And while we're at it, what we might do is select both gate meshes and also change the collision presets to custom. And what I want to do is ignore my targeting line trace, because when I'm close to the gate, I don't want my crosshair to target the gate and then shoot bullets sideways and try to hit the gate. I'm obviously trying to shoot things on the other side of the gate, so we don't need targeting to target our gate. Alrighty. So back to our BP third person character, and what I'm going to do is I'm going to start by tidying up this this logic here. So I'm going to use my favorite thing, custom event, and I'm going to call one apply headshot damage, and I'm going to create another one called apply body damage, or apply body shot damage. Okay. Now, the great thing about these custom events is you can pass different kinds of information. When you call them, you can pass different kinds of information over to then be used on that custom event. So, for example, this hit actor here, if you highlight it, you can see that it is an actor object reference. Okay? Actor object reference. So what you can do is you can highlight this custom event and add an input, and I'm going to call it hit actor, and you can find object types actor object reference. So it's an actor type and object reference. That's denoted by the color here. You can see actor object reference and this color. I actually have color vision deficiency, so I like to not to rely on the colors. But the way this is set up, I can actually see see the difference. It's a bit hard for me, for example, to see the difference between float and vector. I believe that's green and that's yellow, but it's very tricky for me to see with color vision deficiency. So I'd much rather just highlight it and double check. This is a float, this is a vector. So that's the type of data that I'm trying to pass over here. So I can do the same with apply. I'm just going to copy this name, hit actor, and apply body shot damage, add an input, hit actor, and it's already selected an actor object reference. Okay, so I can actually delete these damage actor connections and these execution pins. I'm going to drag this over here. Oops. Plug this in here. Same with my body shot damage. Plug this in here. Okay. And now I'm going to call these events over here off my switch on E physical surface. By the way, I can't figure out how to make this generate the new physical surface without deleting this and replacing it. So I'm just going to delete this and switch on E physical surface again, and then you can see it's added the gate there. What we want to do on body shot is call our apply body shot damage, and on headshot call our apply headshot damage. And you can see we've got these inputs here, hit actor that we added on the custom events. We can plug hit actor into here. Just going to make a reroute node, plug it also into the other one. Now if we happen to hit a zombie but it doesn't call our headshot or body shot damage, we want to apply this damage regardless. So I'm going to get apply body shot damage and just put it on the remaining nodes here. Plug in the hit actor, just in case for some reason it procs a surface type other than headshot or body shot. When we hit a zombie, we want to apply damage to that. Very good. Now we're going to need to do the same down here. We can just delete all of this because we only need it once now over here. And I'm going to duplicate this down here. I'm also going to duplicate my E physical surface, plug in the selection and the execution pin here, and hit actor will go onto this reroute node, default, and gate or apply body shot damage. Actually, we only need one of these. We can plug both of these into, we can actually, just with two of them, we can plug default, gate, and body shot into apply body shot damage, and headshot into apply headshot damage. Sorry about that. That is actually much neater. There we go. Just like so. Now what we can do is also spawn some particle effects, and we will add some sound effects later on, just because it's not something I'm going to walk you through in detail which sound effects to use, etc. We can add some now, but some that aren't included in the packs that we've downloaded so far. I'll just give you some tips later on where you can get them. So I'm going to create another custom event, and I'm going to call it spawn emitter and sound effects. Okay, spawn emitter and sound effects. I'm going to create a few inputs on here. My first input is going to be the location for the hit location. This, if you check here on location, is going to be a vector. So we can change this to type vector, and we can add another one. this is going to be the normal, and this is the basically the angle of the surface that you're hitting, so we can rotate the emitter, the particle effect to come out from the surface. And if you check normal here, normal is also a vector, so that's all good. The other thing I want to do is pass this surface type over. Now this doesn't tell you what type this is, but I can tell you from the color that this is an enum, or enumeration. So it's a list of references or of strings. So this is just a list. It's called an enumeration. So what I can do here is I can add one more, call it surface type, and this is going to be the specific enumeration E physical type. So see there it says E physical surface enum. I can just search for that, E physical surface, E physical surface, and it has that same color, and you can see there it says enum. So we're adding that to that custom event, so it has that output now. We can call this right here. So if we hit anything, we want to spawn emitter and sound effect. Okay, and these can be passed in from surface type, can be passed into surface type. Normal here can be passed into normal, and location into location. That's all we're going to need from there. And we can do the same up on our aiming down the sights. So spawn emitter and sound effects. Just move some of this out here, make a bit more room. Surface type into surface type, normal into normal, location into location, and I'm going to drop this down because we don't need anything more from that. Whoops. Nice. That'll do just like that. So we're calling this custom event spawn emitter and sound effects, and we're passing over the location, the normal, and the physical materials surface type. Okay? So the very first thing here we're going to do is switch on surface type. And then we are going to spawn an emitter at location. So on default, we can do spawn emitter at location. And we're going to duplicate this 2 more times because we're going to do a different one for gate, and we're going to do a different one again for headshot and body shot. And the emitters that we're going to use are part of a pack that we can find. So if we bring up Unreal Marketplace, and we can search for starter VFX and filter by free, you'll find this Realistic Starter VFX Pack Volume 2. I've already added it to my library. If you haven't, add it to your library and then add it to your project. And I'm going to find my first game here and add to project. Now that's added, I can close this and we can find the folder here, Realistic Starter VFX Pack Volume 2, and in particles and hit, we've got these different hit particle effects. I am going to select this asphalt one, and then in my third person character, click the little arrow to set it as this one. And actually I might change the scale to 0.5, 0.5, 0.5, and I'm also going to do that for this other one down here. But on gate, the one that we might use is default because it's just a nice little spark effect. So I'm going to add that one there, and then on headshot or body shot we can find the one that's, I believe it's called blood cone splatter. So what we can do is just drop this one down here and search for blood. Yeah, P blood splat cone. And this one is also way too big, so I'm going to change it to 0.5, 0.5, 0.5. And then the only other thing we need to do is plug in the location and the rotation. So I'm going to plug location in here, create a reroute node, and plug that into all of the locations. And the rotation is a little bit different. What we need to do is get the rotation from X vector, so we can drag off of normal and find rotation from rotation from X vector here, rotation from X vector, and then we are going to get a delta rotator, delta rotator, and then I'm just going to change the value on the y-axis by 90. Okay, and then plug that into the rotation here and make a reroute node, plug this into all of the rotations. So if you ever want to add a new physical surface, you just create the asset, the physical surface asset, like we did here. You add it in the surface list in project settings. You open the physical material and change that surface type to the one that you've added in the list, and then you will need to regenerate this switch on E physical surface because it won't be there until you delete it and regenerate this, as far as I note. And then you'll add a new node, spawn emitter at location, and then you can just plug in the location and plug in the rotation, change the emitter template, and that will be that. So let's try this out, and how I might try it out is just get rid of all of our draw debug types on our line traces, because I don't want those getting in the way. Try this out. Nice. You can see it's rotated to the surfaces there. Very nice. We've got asphalt on there. We've got some sparks on there. And if we shoot our zombies, we should have a blood cone coming out. Nice. Alrighty. Let's get to work on making these zombies attack the gate and subsequently attack our player. If we head back on over to Mixamo and search in animations for zombie attack, you can find this zombie attack animation here. I'm going to download this one without skin, uniform keyframe reduction, leave frames per second at 30 and hit download. And I'm also going to search for hit react and find a nice hit reaction for our zombie. Let's have a look here. This reaction right here. This one will do fine. Hit download without skin, uniform keyframe reduction, 30 frames per second, hit download. And now I'm going to head back on over to the editor, and in my zombies folder in characters and animation, I am going to just import those two animations I just got, the zombie attack and the zombie reaction hit. I'm going to change the skeleton to our war zombie skeleton and import all. And let's open these up and have a look. Got this zombie attack animation here, and the first thing I'm going to do is shorten this up a little bit. So I'm gonna right click. Oh, it's not allowing me to remove. Sometimes it can be a bit funny with what frames it allows you to remove. It's not allowing me to remove anything before frame 17, which is a little bit too much, so I'm not going to do that. But at the end here, I might see if I can remove frame 57 to 80 just to shorten it up just a little bit, and that should be fine like that. I am also going to have a look at the hit reaction animation, and once again, I could stand to shorten this up, but it's not going to allow me to remove anything before about frame 14 or 13. And if we have a look at where that is, that's kind of already in the middle of the reaction. So let's just maybe try and take some off the end. Frame 45 to 61. That'll do. It's good to shorten it up a little bit, but it will have a blend out time as well in the anim montage. And so that's what we're going to do next. We're going to create anim montages from both of these. So right click on zombie attack and create anim montage. I'm going to leave that name as default. Open that up and just change the blend out trigger time to 0.05. Save that, and also right click on the reaction hit and create an anim montage from that. Open it up, change the blend out trigger time to 0.05, save and close that. And now what I want to do is add a default slot to the zombies animation blueprint. So I can open up ABP zombie and go back out to the anim graph. And what I'm going to do is break this connection. I'm going to save locomotion in a cache, so new save cached pose. I am going to copy the name of locomotion here, and I am going to hit F2 and paste that name in there, and then I'm going to call that saved pose, cached pose locomotion down here. I'm going to duplicate that, and I'm going to plug this into a layered blend per bone. So we're going to blend from the spine up on our montages so that our zombie's legs can keep moving if he's moving. Alright, so what I first want to do is check the skeleton of this zombie to check what my branch filter, what bone name is going to be in my branch filter. So let's find our zombie mesh and our skeleton. Open this up. And here I can click character, bones, and all hierarchy to display the hierarchy of bones. And let's have a look what we got here. We've got one called hips, and we've got one called spine, and then spine 1, spine 2, and then it all starts to branch off from spine 2. So what we might do is just do this branch filter on spine. And how these branch filters work is they blend onto everything below the spine. So as you can see here in the hierarchy, you've got hips, and off of hips you've got spine, and then all of these bones above spine are below spine on the hierarchy down here. So everything below spine here, that's what our animation will play on. So what we can do is just hit F2. No, we can't. We can just up here in bone name, we can highlight that and Control C to copy that because we want the bone name to be exactly correct. And in our ABP zombie on layered blend per bone, we can make sure blend mode is on branch filter. And in layer setup, index, branch filters, we want to add a branch filter and then drop that down. Paste our bone name into bone name. Blend depth can stay as 0, and we want to make sure we check mesh space rotation blend and mesh space scale blend. So check both of these. And then the last thing I want to do is drag off of this bottom locomotion here and find a slot, default slot, and then plug that into blend pose 0, hit compile, and you'll see nothing has changed here because everything is working as it should. Basically, below the spine, we have our base pose, and then above the spine, we have the same base pose but with a default slot added in there, so that any anim montages that we play, if we leave them on this group default group, will play in this slot here. It's the only slot we're going to need. So now that we've done that, we can make our zombie attack by just playing a montage. So let's go back to our zombies folder and animation, and in the zombie attack montage, we're going to open this up and we're going to insert an anim notify here. So we've done some anim notifiers already, but this one's going to be a little bit simpler. We're just going to look at the part of the animation where we want him to hit, which is say here. Okay, and then down here in the notifies track, we can right click right there, add notify, and just montage notify. So what this will allow us to do is use a node on the play montage node, a pin on the play montage node to execute some code. So right here, this is going to be where he hits, and you can change this notify name to hit notify or something like that. It doesn't matter too much. Nice. Okay, very good. So we won't need that anymore. We can close that. And what we're going to do is be working in our zombies blueprint. So right here, I can close wave warning. I can close my modular fence. I can close my physical material gate. I don't need that. I don't need the zombie skeleton. I may need the animation blueprint, but right here in BP Zombie is where we're going to be working. So what we want to do once he moves to the gate is check if he's overlapping with the gate and then attack it. What we can do is we can use something called tags. So we are going to change the tag of BP gate so that we can check if what he's overlapping with has that tag, and we can give our player the same tag so that if he overlaps with the player, he'll attack the player as well. So with the root selected here, we can search for tag, and you'll see this actor. It's under actor. There might be multiple types of tags, but we want to change the actor tag, so we can add a tag here, and let's just call the tag ally. Okay, is it Y or IE? I can't remember. Ally. Okay, and we're going to copy that and we're going to use that tag. We're also going to add it in our BP third person character. So here we can search for tag, and here you've got component tags, but here is what we want: actor tags right here. Add one and call it ally. So you can add multiple tags, but basically we're just going to be using the one. So we've tagged our gate and our third person characters as allies, and now we're going to check if we overlap with one of those. So in BP Zombie, what you can do is you can select the capsule component, and actually while we're here, what I might do is just change the capsule radius to something like 65, and I'm also going to add an arrow component here to use for our attack. So what I'm going to do is change the animation mode to use animation asset, and then I'm going to select our zombie attack montage. Okay, and then up here in the components, I'm going to add an arrow component, and I'm going to call it hitbox location. Whoops. Hitbox location. Okay, and I'm going to select that, and I'm going to move it out to about where he hits. So right about there is where we set up our anim notify, and I might just, it depends. You could put this way out here if you wanted. If you wanted to have a crazy hitbox, we're going to try and make it as accurate as possible right here. No Dark Souls 2 hitboxes today. So with that arrow component there, that's all good. We're going to use that in a moment. But right now, what we need to do is make sure we change this back to use animation blueprint. Make sure you switch this back to use animation blueprint, or you will have some strange results where he's just attacking. It's the only animation he does. So we're going to select this capsule component, and then we're going to scroll down in the details panel, and you'll find these events here. We can use on component begin overlap and on component end overlap. So we can click this and it will add this node. We can also click end overlap and it will add this node. Nice. And we're going to check if the other actor has tag. So we can actor has tag. And then I don't know if we've still got this. Yes, we've still got this copied. So ally, put ally in there, and a branch. Okay. So if we overlap, if the capsule component overlaps with another actor and that actor has the tag ally, then we're going to set a variable. I'm just going to call it is overlapping ? That's going to be a Boolean. We're going to set that here as true. And down here on component end overlap, we're going to set it as false. Now you're going to have to bear with me here. We've got quite a lot to add to our zombie. And we will get there in the end. Just stick with me and follow along, and we will get there in the end. So when we overlap with the component, when the capsule component overlaps with an actor that has the tag ally, we want to attack. So I'm going to create a custom event. I'm going to call it attack. And then I'm going to call that here attack. Okay. And the attack is going to be our attack montage. So we can grab the mesh and we can go play montage. Plug in the execution pin. Select our zombie attack montage. Zombie attack montage. Very good. And on the notify begin is where we're going to hit that notify, and we're going to cause our damage. But on completed, we just want to do a couple of things here. On completed, let's check if we're still overlapping. So grab is overlapping and a branch. And what we might do is put a delay here on both of these nodes. So when our attack is completed, if we are still overlapping, we want to attack again. It's going to keep attacking. And if we aren't overlapping, what we want to do is follow the player. So I don't believe we set up follow player yet. We just have move to gate. So I might just put it down here. I'm going to create a new custom event. Call it follow player. And I'm going to call that right here. Follow player. So if we're finished attacking and we're not overlapping with an ally anymore, we're going to start moving towards the player. When we move towards the player, what we first might want to do is set our zombie's movement a bit faster. So let's set the max walk speed as, let's say, 450. Not quite as fast as our player, but still pretty fast for a zombie. And then we can use our AI move to node, which you've already started to become familiar with. So we can, off of here, we can find our AI move to. the pawn that's moving is going to be a reference to self. And we can set the destination like we did with the gate location, or we can set a target actor. So what we can do here is get player controller, get player controller of index 0, so that's going to be us, and it's going to chase us. I might change the acceptance radius to 1 here, but it doesn't matter too much. Now, if our zombie fails to move to our character, we want to just try again. So on fail, we're just going to call follow player again. And on success, we're going to attack. But if we just say attack now, it will attack over and over again. It will keep interrupting that montage. So what we're going to do is a do once. Okay, so just one time we're going to attack. And then I'm going to delay for 2 seconds. And then I'm going to put this on a sequence. And the first thing I'm going to do on the sequence is reset the do once. Okay, so I'm going to put a couple of reroute nodes here. So it's going to do it once, and then after 2 seconds, it's going to reset that do once, so it's able to attack again. We could set a boolean and do a branch, but this is just one way of doing it, and I'm introducing you to a new node here, do once. This can be very useful for things that you really do just want to happen once. Do once, and then if it's done, it won't do it again. But here we're resetting it after 2 seconds, and then we are following the player again. Nice. So on success of reaching the player, it is going to attack, and then after 2 seconds, it is going to reset the ability to attack when it reaches the player, and it's going to follow the player again. Nice. This is all starting to shape up pretty well. What we might do on end overlap as well is follow player. We want to call follow player like quite a lot. We will call follow player on event any damage as well. So on event any damage, we want the zombie to be aggroed. So we are going to follow the player. We can just do this. We'll get rid of this health print string. We know that it's working. We don't need that anymore. And I'll call follow player in here. What else can we do as part of the damage? We can add our hit react. I knew I was forgetting something. So on event any damage, I'm going to get my mesh and I'm going to play montage. And the montage I'm going to play is my hit reaction montage. Very good. And then when we complete that montage, I think we should check is overlapping. So on completed, check if we're overlapping. And if we are overlapping, I might just delay by 0.2 of a second just to leave a bit of a gap. This is kind of like a forgiving mechanic. So if you shoot the zombie, it's going to interrupt any attack montage it's doing because it's going to play this one instead. And then after 0.2 of a second, it can attack again. If it's not overlapping after it's been hit, we want to follow player. Like I said, we call this one quite a lot because we want the zombies to follow and attack the player. Just make sure I plug these back in up here. That's pretty good the way it is. I think that's pretty much everything with the following and the attacking and the hit reactions, but we just need to do some damage logic on the attack one right here. I'm just going to move this one up here because we're going to do this on notify begin on the attack zombie attack montage. But what I'm going to do first is I'm going to introduce you to something called a blueprint interface. So we have been casting quite a lot, like on event begin notify, we could cast to the gate, but this is actually very expensive. This is resource intensive casting. So what we can use is something called blueprint interfaces. Now I'll walk you through this as we create it, but what I'm going to do is go to my main folder and create a new folder, and I'm just going to call it interfaces, and then in interfaces I'm going to right click, and it's going to be in blueprint, right click blueprint and blueprint interface, and I'm going to call this BPI for blueprint interface underscore destroy gate. It's not going to destroy it, it's going to knock it down, but this works for now. I'm also going to just grab this destroy gate part of the name and control C it, because if I open up this blueprint interface, you'll see that the first thing it assumes is that you want to rename the function. So we can paste that in and rename the function destroy gate. And that is literally all we need to do in here, because this blueprint interface is not where you execute code. It is basically a message that gets sent out, and anything with this interface added in its class defaults can potentially receive that message. So it could be a lot to wrap your head around, but follow along, it will be fine. So we've created BPI destroy gate, we've renamed the function, and now we can close that. We don't need to use it at all. And then in our gates blueprint, we are going to click on the class settings here, and over here you'll see interfaces and implemented interfaces. We can now add this BPI destroy gate that we've just created, and then you'll see it has appeared over here in this section called interfaces. We can then either right click on this and implement event, or we can just double click on it and it will add this to the event graph here. So if our zombie sends out this message in its blueprint, it will be received here and it will do whatever we attach to here. So in our zombies blueprint, what we can do is get overlapping actors, and I'm going to change the class filter to our gate, BP gate, and then on overlapping actors we can get a copy. So this is basically getting the copy of the gate with the index 0. So it's going to get the first overlapping actor basically. It's kind of hard to explain, but the object reference is now a reference to the first overlapping actor of the class filter BP gate. So whatever gate we're overlapping with. This is handy stuff right here. And then we are going to call our BPI destroy gate, this one with message, destroy gate message. It has this little mail icon here. It's sending out a message to anything with destroy gate, and if it's our first overlapping actor of type BP gate and that's had destroy gate BPI added to it, it will activate this code there. So on notify begin, we're going to destroy the gate, and what we're going to do in the gate is we are just going to reduce the angle of it. So on destroy gate here, what we can do is we can create a variable, call it gate angle, for lack of a better name, and we'll call it a float. And I'm going to check if this is less than 2. I don't really know why it's 2. I would have thought that with the way we're going to set this up, it would be in degrees, but here we are. This is what makes it work. And as I said before, it doesn't matter how you make things work, it only matters about the result. So what we're going to do, if our gate angle is less than 2, we're going to set our gate angle. And what we're going to do is we're going to set it as the current gate angle plus 0.1. So it should take 20 hits for this to reach 2, and when it reaches 2, it's going to fall down when it reaches a certain angle. So what we can do here is set actor rotation. The target's going to be itself. We're going to set the rotation of the gate, and we're going to right click on the rotation pin and split the struct pin, and we are going to get the current actor rotation, get the actor rotation, and we're also going to split this, and we're only going to change it on the x-axis. So the y-axis and the z-axis we can plug straight in there, so it's going to set it as what it is. And here we are just going to add this to the current x and set it as the new x here. So every time it hits, it's going to add some angle to the gate. And then when it reaches a certain angle, which is anything greater than 2, so once it's been hit 20 times, we're going to do some stuff down here. I'm going to call a sequence first because I'm going to do a couple of different things. Actually, off of here is where I'm going to play my sound, which is what I'm going to talk you through a bit later on. On 0 here, I'm going to add a timeline, and I'm going to call it gate falling timeline, something like that. Failing? You can say that again. Gate falling timeline. So off of here we can also set the actor rotation. And what I can do is I can grab this get actor rotation and duplicate it down here. I can right click here and split the struct pin because we're not going to change the Z or the Y. We're only going to change the X. And what we're going to change it with is a map range clamped. So we can double click on this gate falling timeline, add a new float track, and why don't I make the time 1.5, and I'm going to add a few points here because I want it to start off kind of slow, but then I want it to fall faster the further it falls, just like a gate would. So this one's going to be time 0 and value 0, and this one's going to be time 1.5, and let's just make the value 90 for 90 degrees. I'm going to zoom out and fit here. Whoops. Where's my other? 1.5. Value 90. I'm not zoomed all the way out. There we go. Whoa, what's going on here? It's zooming to the ones I've got selected. Okay. I'm going to select all of these and right click and select auto. I'm going to make this go down like this, and I'm going to make these smooth this out a little bit like so that it's steeper towards the end here. but it also doesn't go below this line here. We don't want the angle to go into the negative. Very good. So it'll start falling, and then around here it'll start really falling, and this one's just not quite smooth enough. There we go. That will do. Very nice. Okay, so our minimum value is 0 and our maximum is 90. So off of here we can get a map range clamped, and the in range is going to be 0 to 90 as we just saw in the timeline. The out range A is going to be the current X, and the out range B is going to be 90. This will change this value wherever it is between 0 and 90. 0 will become our current X, and the output, the end point, will be 90 degrees. So we'll always finish at 90 degrees. Nice. And what we also might do off of this gate falling logic is just turn off all the collisions so that our zombies are no longer overlapping with it. So I'm going to get a delay here. I'm going to make it ½ a second. And then we're going to get all of our components here and drag them out. And I'm going to set collision enabled as no collision. So this isn't enabling collision. This is changing the setting of collision enabled to no collision. So you can also set it to on, you can set it to all this different stuff. But here we're setting it to no collision. Plug in all the targets here and the execution pins. Nice. We're actually getting pretty close here, guys. So we've got our destroy the fence logic. We now just want our repair the fence logic. So we're going to use another blueprint interface. So I can go to my interfaces folder and create another one in blueprint interface. I'm going to call this BPI underscore repair gate. I copy that repair gate and open this up, paste it into the function name, compile, save, and close that. And then in BP gate, what we can do in the class settings is add another implemented interface, repair gate. It will appear over here, and we can double click on that, and then we've got our repair gate node here. We want to do exactly what we did here in our third person character. So I'm going to grab these two, Control C them, go to my third person character, and I'm just going to find some empty space and find the F key, and I don't know if maybe I should make a boolean on this. Yeah, because I want to make this mechanic where I'm holding the key to repair it, and only if you are holding it will it repair. So I'm going to add a boolean is repairing ? And I'm going to set this off of pressed as true and off of released as false. I want to have to hold this for 2.5 seconds or whatever you want to set it to be able to repair. So I'm going to put a delay here. Actually, I'm just going to make it 2 seconds, a little bit more forgiving. And then after 2 seconds, we want to check if we're still holding the repair button. So I'm going to get is repairing and a branch. And then if I am still repairing, like if I am still holding the key, then I want to repair. And I'll see if nope, I haven't got those anymore. So I'm just going to go to my BP zombie, grab these again, Control C, just to save 3 seconds, and paste those in here. class filter BP gate, get the first overlapping actor, and call our repair gate message. And then we want to loop this back to the delay. So after it sends the message, it will loop back to the delay. And then after 2 more seconds, if we're still holding it, it will continue to repair. If we release the F key, it will break this loop. So as long as we're holding it, every 2 seconds, it will repair the gate. And in the gate, we can do the repair gate logic now. And it's going to be basically the same as this stuff here. So we can grab this here, duplicate it down here. Except now what I'm going to do is change this to minus 0.1. And I'm also going to change this to the current X minus the gate angle. Like so. Nice. Now, we're almost there, guys. Let's do our attack logic for hitting the player. So we've got the attack logic for when our zombie attacks the gate, but then also what we want to do is attack the player if we're, if we're overlapping with the player or we're near the player, we want to cause some damage there. So what we can do is we can use a little node that spawns a little sphere to use for overlapping with things. So we can look for sphere overlap actors, okay? And the sphere position is going to be this hitbox location that we created. So we can grab hitbox location, whoops, that's not hitbox location, and get world it's because it's not a vector, it's an object, my bad. Hitbox location, and then we can get the world location. Get the world location, plug that into there, and let's make the sphere radius 40, something like that. Now off of object types, we need to make array. And the object types that we're looking for are pawns, so characters. And we can also drag off of actors to ignore and make array. And we just want a reference to self. We don't want the zombie to damage itself, so ignore itself. And we can change the actor class filter to our characters player. So BP third person character, very good. And the next thing we want to do is check if we hit anything. So when there's a return value here and it's a boolean, it's quite often good practice to just do a branch off it, like with your line trace. Check if we actually hit anything. And then we are going to, off of true, if we do hit anything, we can do a for each loop. And the array will be our out actors here. Plug that in there. And then the array element that we've hit, we can apply damage. That will plug into loop body there. Base damage can be 10. Event instigator, we can do get controller. And damage causer is the self. Damage type class can be damage type. Just change that to our damage type. Now, we want this to actually hurt the player, so we need to do the event any damage in our third person character's blueprint. So we can find some empty space, and I don't believe we've done any event any damage yet, so I can just call it down here, event any damage. And we're going to need a health variable. So let's add a health variable. Health. Call it a float. Compile and save and change the default value of the health to 100. And what we're going to do now is we'll check if the health is more than 0. If it's greater than 0, then we're obviously still alive. And if we are still alive, we want to set that health as set health as the current health minus the damage. Very good. And while we're here, we might as well put in some death logic and do a hit reaction and all of that. So we actually have a hit reaction in our anim starter pack, retargeted UE5 anims. And then if I look for hit react, there's a few here. I quite like hit react 4. You can play a bunch of random ones, but this one is probably the most kind of exaggerated. It's a good looking little animation. I might just see if I could tighten that up at all. Yeah, I could definitely remove some frames from the end. From about 24 onwards, yep, remove frame 26 to 30, but that's about it. We don't need to go crazy. We can then right click on that and create anim montage, leave the name as default, but open it up and change the blend out trigger time to 0.05. Save and close that. And now each time we cop damage, we want to play that montage, so we can grab our mesh here, play montage, and the montage to play will have that one selected, and just click the little arrow to set it. Very good. And after that we can check if we've run out of health, and if we have, then we can die. So I'll create a custom event, call it death, and then up here we can just get health and check if it's less or equal to 0. Make a branch. If it's less or equal to 0, then we can call our death. Okay. And if false, just do nothing. Death, what we can do is we can just do the same as with our zombie. We can do some ragdoll physics. So if we check our zombie and our death logic here, we can basically take all 4 of these nodes, copy them, paste them in here. The target on the first 3 is going to be our mesh, so we can grab our mesh, plug it into these targets, and this one is for our capsule component. It doesn't matter too much. But then what we might also do is set what's it called? It's disable input. Disable the input. And that doesn't need a player controller. That's it. That should work. Guys, I think that's pretty much it. Unless there's something I'm forgetting, that is pretty much it. So let's hit play and let's have a look at how this works, huh? These guys are moving in. they're not attacking. They're not attacking, so we need to figure something out here. And also, one thing I did forget that I've just remembered is our pawn sensing component. So here, what we can do is we can add something called a pawn sensing component, and it will add, you can see here, it's added pawn sensing here down below this divider. It is a bunch of sight radiuses and hearing radiuses and stuff like that, and we can use this to detect our player. So what I might do is just change the sight radius to 2000 for 20 meters. Let's make it 1000. They're dumb zombies. So here we have our sight radius here, 10 meters. If we get within 10 meters of the player, you can even change the angle so that you can change the peripheral vision angle here to say 70. So there's our sight radius there in a cone in front of the zombie. And if he sees us, we want him to chase us. So down here on events, you can see on see pawn. We can click that, and on see pawn, we can just call follow player. Now what's going on with this overlap and attacking? It's not working. So we're checking if the other actor is called ally. So straight away we can check if we've done that correctly. Yes, we have the tag ally. Very good. And if so, attack. An attack should play, at the very least, this attack montage. Strange. Strange that that's not working. This guy can be our canary in the coal mine. We don't have to wait for the wave to start. Yeah, he's attacking. Is it setting? It is setting the angle of the gate. Oh, and they're attacking now. Ah, I see. They were blocked from moving to the gate. So what we want to do is make sure that on move to gate, we put move to gate or move to player on fail. Where did we put move to gate? Follow player. Ah, it's just right here. Move to gate. So on success, it won't matter because they'll be at the gate, they'll be overlapping, and they'll start attacking. But on fail, we'll put follow player. And you know, why not? Let's put follow player on success as well. And while we're here, before we test absolutely everything, let's add our health to our viewport. So in our HUD folder and UI main, what we can do is grab what's called a progress bar right here. I'm going to drop it right here. And because I'm a Dark Souls fan, I'm going to make it nice and thin. I am going to change the percent here to full, so you can see here, you can play around with the percent. I'm going to change it to 1 and change the fill color to red because I'm a massive Dark Souls fan. I can change the anchors to the top left if they're not already, and that's where we want it, right there. And then what we can do is bind the percentage. So we can create a binding, and then right here we're going to cast to our third person character blueprint. The object will be get player pawn. As BP third person character, we can get our health, and then because as you saw the percentage goes up to 1, the value is between 0 and 1, so we just need to multiply this by 0.01. Plug it in here. And now if we hit play, we've got a health bar. We've got our wave starting here. This guy's attacking the gate. We can kill one zombie just to make sure that's working. Killing zombies is not working, so we got something to debug there. But if they're not attacking me either. It might just be something to do with the overlapping. So we first want to double check that our BP third person character has that tag ally, and it does. They're also not doing the hit reaction. So it has something to do with the custom event we made over here. That was quite dumb. I never plugged in the hit actor into damage actor. Sorry about that. The reason I didn't plug it in when we first created these is because I wanted to show you that when we add these inputs to the custom event and then we call them, we plug it in, and then I meant to come back and say, and then we plug in this into there. So what this is doing is it's calling the custom event, it's passing this information in here, and then where the custom event is called, we have access to that information to then pass it on. So instead of dragging this and plugging it all the way over into here, we just pass it through the custom event, pass everything we need through the custom event like we have here, and plug it into where we need. My mistake, we hadn't plugged in damage actor there. And we also need to figure out why our zombie is not attacking. All it is, guys, is the ability for these pawns to overlap because their capsule components are blocking each other and they're failing to overlap. So let's just add another capsule collision to each character, and I'm just going to call this one overlap capsule. I'm going to copy that, and then we just want to scale this up so that it is slightly larger than our capsule component. So that one's 65 radius, so I'm going to make this one 75. Whoops, that's not right. Capsule radius isn't really working. Capsule half height 90. Let's make sure that's the same. Because it's a capsule, it will only be able to be as wide as it is tall. I wonder if we can just have a sphere radius. What I might do is just add a sphere collision, and that's going to be overlap sphere. Copy that, and then sphere radius 100. Nice, so if they overlap with that, they'll be able to hit us. And we just want to make sure that collision presets is, we might want to have that as custom overlap. We definitely don't want these to block our line traces, and everything else can just be on overlap. Okay, so we might even just be able to copy that component, Control C it, and then Control V it in the zombie blueprint. That looks fine. Collision did not copy over, so make sure that you ignore projectile and targeting and block everything else, and that should be all good to go. Now I've moved my zombies over here and I've changed the number just down to 1 because I just need 1, and now he's attacking, he's hitting me, my health is going down, his health is going down, and he's dying. That is pretty much it, guys. I'm going to... Oh, I forgot I've got more spawning here. Better look out. Yeah, that's all working fine. So let's have a look at downloading and adding some sounds to our project. And that will tie things up. Alrighty. Alrighty, guys, if you haven't heard of it already, there's this site called freesound.org. You can sign up to this site and you can download hundreds of thousands of sound effects that are created and uploaded by different members. They have ratings and whatnot. Now, a lot of the stuff you'll find is not very high quality, but if you're prototyping or you're playing around and making your first game in Unreal Engine 5, as we are here, then this is a great resource. So I've downloaded a bunch of different sounds from here, and I have also, in Unreal Marketplace, I have found this interface and item sounds pack. I've only got one sound that I'm using from here, and it's the alarm sound that you hear when the wave is starting, but I wanted to point you guys onto this one as well, in case it has any other sounds that you think you might want to use. So I've added this to my project, and I've also downloaded a bunch of sounds from Freesound, and I have created a new folder in my _main called sound effects, and I've imported my Freesound sounds. And now let's go ahead and use some of these. So this one here is quite a long, and if I press play here, that's actually not the right one. This was one that I was getting for hit reactions for my character. The one that I was looking for is actually this one: dog groaning, moaning, sniffing. This is quite a long audio track of what sounds like a dog groaning. I thought this would be a nice touch to add to my zombie. So what I'm going to do in my BP zombie is actually just add a audio, and right here you can see that's the one that I was looking for right here. I'm going to add that one to my character right there, and I'm going to change the volume multiplier to 0.1 because it's actually really quite loud. Okay, so that's one sound that we've got here, and actually I don't want this to play after my zombie dies. So what I'm going to do is go into my BP zombies event graph and find my death logic, which is right here. So when death is applied right here, I am going to grab this component and I'm going to set the sound. What I'm going to change it to is a death sound. So I've got, bear with me here, that's my gate being hit, that's my character being hit, and a different one as well, two different character reaction hits. That's my gate falling, and I've got this one just for my zombie dying. And this is an alternate gate falling sound. So this one right here is the one I'm looking for. I'm going to select it, highlight it, and then I'm gonna click the little arrow here so that when my zombie dies it changes to that sound. What else have we got? So let's do our hit reactions on our character. On event any damage right here, we've got the montage playing. So right when we play our montage, we can also play a sound. We can play sound at location, and I've actually got these two, so I want to play them randomly, one of these two. So what I'm going to do is actually put a sequence here, and the first thing I'm going to do on the sequence is just check my health and cause the death. And actually, yeah, I might, instead of putting a sequence here, I might just put it on this branch. So if we're not dead, we'll play the hit reaction sounds, and then if we are dead, maybe we could add a different sound. On the death, we could add a different sound. So off of false here, what I'm going to do is get a multi-gate, and I'm gonna check is random and loop, because I'm going to have it randomly select one of these sounds, and you can add as many as you like here. And I just need to apply these sounds. So which ones were they? These two here. So I'm going to select the first one, click the little arrow, select the second one, click the little arrow, and then the location can just be the world location of our mesh. So we can grab our mesh here, whoops, get world location, plug that into the location. And you probably want to play around with the volume modifiers and stuff like that. So I'm going to make this one 0.5 and 0.5. Turn the volume down a little bit. And let's also do some noises when we hit stuff. So we did our spawn emitter and sound effects right here, and now over here in that logic we just need to play some corresponding sounds right here. So off of the end here we can do play sound at location, and I can duplicate this, and the location is going to be this hit location right here, already very handily set up for us. Plug in the location, and now we just need some sounds for this stuff. If we look in our weapons folder, it's got some sounds, and actually what I might do is just highlight military weapons dark, and then I am going to search for a filter called sound cue. It's not coming up, hold on. Here we go, sound cue. And then we've got a bunch of different cues for sounds within our military weapons folder. The one for hitting asphalt, I believe I like, is shotgun impact surface cue. That's fine. Shotgun impact surface cue, we can select that. And then on asphalt right here, I can click the little arrow and default, and then gate is going to be more of like a ping sound. I believe there is a rifle hit sound, rifle impact surface. That's not the one. Here we go, rifle impact surface cue. That's a nice little, sounds like a metallic hit. So we can select that one and then assign it here on gate. And then the blood splat one is going to be body impact. So maybe sniper rifle was the one I was thinking of. Impact body. This one. That sounds nice and meaty. So I'm going to select that one and assign it here. Now, am I forgetting any? We've got the surfaces, asphalt, the gate, we've got the body hits, we've got our hit reactions, we've got their death reactions. I believe that's pretty much everything. So what I'm going to do is get my spawn location, and I'm going to get it by dropping my zombie. I'm just going to turn this filter off, this sound cue filter, and grab my zombie and put it here, and copy the location, delete the zombie, go to my BP game mode and change my spawn location's default value back to something in there. And then what I also might do is select my lights here. Just trying to select both of them. I got a shift click. That one's in the wall. When I moved the walls, I forgot to move my lights. That's fine. We got both of these here. I can Alt and Shift and drag this one further down. And yes, I've got both. And I might just want to point one forward and one back or something like that. Ah, I've still got both selected. My bad. Just select one. Point this one forward. This one can stay pointing back. Nice. And I just need to change my current wave multiplier back to 3 because I changed it to 1 for debugging. And now if I compile and save, I might just hit save all as a ritualistic thing because I'm pretty much done here. If I hit play, let's see how this all works. Sounds are playing on the zombies. Sounds are playing on the emitter location. Very good. Zombies are dying. Let's check our repair here. So if I hold F, every 2 seconds it's going to repair. Very nice. And the only thing that I have forgotten to add is the sound of the gate when the zombies hit it, or I repair it. So, and the sound of the gate falling as well. So BP gate is the very last thing we need to do, guys. We're almost there. What I want to do every time I set the angle here is I want to play a sound at location. Play sound at location. I can just get actor location. Actually, what I might do is this location here is where this widget is. So I'm going to grab my right hand panel here. I'm just going to pull it up to get the location of right in the center of the gate here. And I'm going to right click and copy that location, and then I'm going to undo that move and then go back to my event graph, and I am going to promote this to a variable. I'm just going to leave it as location because I'm lazy. Compile and save, and then right click in the default value and paste in that location. Very good. And we need to find my sound, some main sound effects, and it's the gate. There's a gate falling. That's also a gate falling. Metal boom. This is the one I'm looking for, so I'm going to click that one and assign it here. And I'm going to play the exact same one when I repair the gate. Once again, because I'm lazy. You guys can do whatever you like. Have fun playing around, downloading different sounds and adding them in. It's sound design. It's quite a fun little break from programming. And then what I want to do is also play this sound when my gate falls. So I will just duplicate this. But I do want to play with my timing on this one because I want it to be, so is it this one and this one? I quite like this one, so I might try that. BP gate, put that in here, and I might actually just delay this by 1 second, the actual gate falling, so it starts off even slower. Delay by 1 second while it starts playing the sound. You'll start hearing the sound, then it will fall. Very nice. Let's try it out. Ah, the alarm sound. My bad. The alarm sound is the very last thing that we need to add. It's in the folder interface and item sounds, and then cues. And then I found this futuristic alarm right here. This is actually quite a long sound, so I'm going to start it 5 seconds in because I think it's about 10 seconds long actually. And I'm going to call this my game mode when my waves start. So at the very start of the game, where we started right here, I am going to play the sound right here. And the location, I might just put it in the tunnel. So I might just grab my spawn location and just plug the spawn location in right here. Vector, transform. So I can split this and just get the location. Okay. And the sound that I want is my futuristic alarm cue. Make sure I've got that selected. Set that right here. And I'm also going to need that when I increment my wave. So as the warning comes up, it's going to play that sound. Very nice. I'm pretty sure that's absolutely everything, guys. It's been a long road to get here. I'm sure you didn't put it all together in one sitting. I certainly didn't put this tutorial together all in one sitting. But we're pretty much there. I just forgot to change the start time on my alarm to 5 seconds. I'm going to change that to 5 seconds, and I'm going to change the volume multiplier to 0.25. So I need to do it down here as well. 0.25, and start time 5 seconds. What we might do, guys, is just have an actual go at this game to see how we go, okay? And to test everything out. So, nice, the alarm and the warning. I like how that's working. Very good. Ah, they're not attacking repeatedly. So I did find a bug. There we go, we found a bug pretty quick. That's going to be in our BP zombie, and it's going to be part of the attack logic. Attack, and on completed, it should be checking is overlapping and then just attacking again. Which it isn't. On completed of that, check is overlapping and attack again. That really should be working. Let's just hit play. And with a debug selected there, we can check if this is actually firing off. Just gonna aggro my zombies so that they come in a bit faster. Attack. Oh, there we go. Huh. Strange that that wasn't really working. Maybe it has something to do with interrupting them. Nope, they're still doing it. I really don't know what caused that, guys. I don't think I should have any bugs still, but you never know. I mean, these guys are running in very fast. I think they're actually hearing the sound of the gate repairing. Let's let these guys knock the gate down so we can check the how the sound lines up and all that. Hey, that's working quite nicely. Very good. Come on. Come on. Come on. Break the door down. Let's go. So there seems to be some issue with them attacking the door. I might get back to you on that one, but for the most part, it's all working pretty well. These guys are chasing me. They're attacking me. Nice. I only just got out of the way of that attack, so pretty unforgiving. The setup that we got here. These guys are not just total walkovers. And I just want to check that that sound is stopping when they die. I wasn't paying attention to it before. So we'll leave one alive here. He's not actually playing the sound, it's a bit odd. It's all working pretty well. Guys, that's it. If this tutorial has been of any use or value to you whatsoever, please hit like and subscribe if you haven't already. And also, I've set up supers on YouTube so you can thank me via YouTube. Right there, there's a thanks button where you can donate, make a small donation to the channel if you're so inclined. It would be very much appreciated, and it will keep me going because I am going to be making more tutorials like this. I'm also going to go on and make a first-person shooter with a metahuman very soon. So yeah, stay tuned, and guys, I will see you on the next one.